Hold on 1 second. All right, so just a note to self, we are recording. So, all right. So type 1 hypervisors basically run directly on bare metal, right? And these are the most efficient hypervisors. Especially now is that the efficiency of these hypervisors is just kind of sick, honestly. You're using it somewhere between 2 to 3% performance loss, even with mixed virtual machine types on top of systems. Virtualization has gotten so ridiculously fast, right? From a virtual machine standpoint. Notice that the type 1 hypervisors here are like Zen, they say Citrix Zen Server, just so you know, there is an open source project called Zen as well. Then ESX, KVM, Hyper-V, et cetera, right? Oracle VM server for Spark. Man, they even sell Spark machines anymore? It's really old. Anyway, so those are type 1 hypervisors. The type 2s are the ones that we're aware of. Fusion, Workstation, VirtualBox, even Hyper-V, which I'm kind of listed. Interesting that Hyper-V is listed here because Hyper-V doesn't, I don't know if they have a bare metal version. I'm not really that well versed in the deeper aspects of the Windows ecosystem, but I think actually they're a type 2 hypervisor, but you know, someone probably knows more than I. So the processing is a little different, right? Because if I have a type 1 hypervisor, then all I have on there is the core necessities necessary to run virtual machines. If I'm running a full host operating system, I usually have a bunch of extra cruft on there that I don't actually need, like a graphical interface, for example. Probably don't need that for a hypervisor. Now, again, just highlighting the difference, this is not necessarily going to be a key differentiator for you to understand containers. It's just to understand a little bit of the history around virtualization. We're going to skip pair of virtualization. All right, so here's some qualities of virtualization, right? Transparent sharing of resources, right? Decouples hardware from software, allows you to aggregate hardware into a shareable pool, right? You can do live migration, right? But that only works, by the way, with key virtualization initiatives. It doesn't work with everyone. Isolation, so you can limit your security exposure and reduce the spread of risk, right? So instead of having multiple applications sitting on the same operating system, you can now have multiple operating systems per application. Extend that for containerization, and you can now have multiple isolated processes sitting on the same operating system. How isolated? That depends on how you configure it. Obviously, management gets a little bit more complex, actually. Can you imagine 49,000 and change containers running across the entire ecosystem? You're not managing that manually, right? You've got an automated system that automatically monitors, self-heals, scales, like makes sure the containers are performant. That's what Kubernetes is actually for, is for the production run of containers, right? Because it does auto scaling and self-healing, right? Both on a pod level and can do it on a node level as well, right? Kubernetes can enforce security policies. It can enforce access policies, right? And so that's what we're using Kubernetes for, is to enhance all those pieces. Obviously, and just say this, Kubernetes also provides high availability. Why? Because you've got a clusters of hardware nodes. You can also start nodes and contract nodes as it sees fit. And so it's going to make sure that, you know, n number of your containers are running at any given time. Now, these disadvantages for virtualization also apply to a certain degree with containers, maybe not so much, right? So in this particular case, the disadvantage of specifically of virtual machines is that you have to boot an entire operating system. You do not actually need an operating system inside of a container. You don't. You could run Java and have nothing else in the container except for Java and any of the third-party libraries you needed, including the JVM if necessary, right, to run Java. But you don't actually need an operating system in your containerization. For virtual machines, you have to have an operating system. Otherwise, the virtual machine won't boot, right? So one cool thing here also is that virtualization overhead does increase precipitously with virtual machines if you add a number of virtual machines running on the same physical box. If you were to take that same box and replace those virtual machines with containers, especially if the containers were heterogeneous, you would get a lot deeper density of containers on that same piece of hardware. Because just to be clear, is that unless it's a number crunching, data intensive algorithm running of some type, your systems peak and valley at different times. So if you're running a shared workload across a Kubernetes box that isn't single purpose, everything's going to peak and valley at different times. So you're maximizing the spread of consumption across the entire cluster. But I got to tell you, if it's just so you know, I favor cluster as a service. If I'm working with a company like Honeywell, for example, that has a data science team, that data science team gets its own cluster separate from everybody else. Why? Because they're literally trying to crush that system at any given time to maximize the parallelization and how they're running data models. That's not going to work, dude. That's not a mixed workload, by the way. They're trying to run those things 24/7. They're queuing them up. And so that thing's running at 90, 95% all the time. I'm not going to put them in with a bunch of other people who are all peaking and valleying at any given day with workloads. So again, just realize that you also need to think about the profile of your cluster as you walk through Kubernetes and Docker in particular. Now, we've already touched on this, but containerization is nothing more than process isolation. It's just process virtualization. Does it have virtualized storage? It can. Does it have virtualized networking? Definitely. Is it virtualizing the processor and memory? No, not really. You can put limits on it, but it's not really giving you a virtual set of processors or a virtual set of memory. That's why like the whole containerization as virtual machines thing doesn't really work, because virtual machines actually have their own processors, virtual processors, and slice of memory like virtualized out to them. Containerization doesn't really do that, right? So it says, for example, a container encapsulates an application running inside its own operating environment, which is derived from the underlying host OS. That's bullet number 2. Guess what? That's true. In other words, the only thing that needs to have an operating system is where the container and the containerization software are running. That's it. You don't need a container inside your operating system. You don't have to have one, right? just to say this, that bullet number 4, might want to take a note, is patently false. The most widely used technology behind containerization is Linux containers. That's not true anymore. That actually just shifted as of 1.20 of Kubernetes. 1.20 of Kubernetes actually uses a very different underlying back end, which we'll get to when we get to Kubernetes. I do want to mention one thing. People talk about containerization as if you can like pivot to any kind of architecture. But I want to make sure there's one clear distinction. If you create a Linux container that's made for Linux x64, like just a standard, kind of Intel set of architecture, both Intel and AMD, that binary, for example, that if you build it for Linux x64, it will not run on Windows. Doesn't matter if it's in a container, right? If you run something, you make a Windows container and you have a binary in there that's meant for Windows x64, it's not going to run on a Linux Kubernetes cluster. You actually have to have Windows x86 for Windows x86 binaries, and you have to have Linux x86 host for Linux x86 binaries. That includes if it's Linux PPC or Linux ARM. If there's different CPU architectures and the binary that you're running either isn't running, or you don't have an interpreter for an interpreted language for the thing in question, you cannot mix and match containers on different processor architectures unless you have an interpreter built for that architecture. Most people think that once you like Java, remember Java, you write once, run it everywhere. That is kind of true. You have to have an interpreter on every single piece of architecture that you want to run that Java code on. Containerization is no different. The interpreter for the code must exist either in your container or on the host operating system, most likely on the host operating system. So I want to make sure that's incredibly clear. Windows on Windows, Linux on Linux, Linux ARM on Linux ARM, Linux PPC on Linux PPC, right? You have to run it wherever the container was built for. That's where you can run the particular architecture. So you might be saying, well, Michael, hold on, Michael. I'm on Windows and I'm running Linux containers on Windows using Minikube. And you are, because Minikube is running a Linux operating system inside of it. It's not running a Windows operating system, right? Is anyone that doesn't understand that? Okay. So make sure that's clear. That's why, by the way, in a moment, when we look at hub.docker.com, you're going to see a lot of CPU architectures listed as tags for the containers. Because if they're on ARM, for example, which is a type of CPU architecture, you're going to have to pull ARM down, right? Versus x86 versus other processors, right? So at this point, I think starting from Windows 2016 or in Windows 2019 definitely has it. And pretty much any Linux kernel that's been published in the last 5 years has the ability to support containerization natively. So you don't need to worry about whether or not it can support it. You just need to make sure that you have the right architecture. Okay. We already talked about a little bit of the concept of the comparison. The main thing to remember is that when we talk about process virtualization with containers versus virtual machine containerization, we're talking about very different requirements, including what the translation software is. Remember, virtual machines tend to be bigger in size, both from a memory standpoint and a disk standpoint, because they require a minimal operating system to run on them. Containers just require the application and whatever other libraries are necessary. So containers are really tiny compared to virtual machines. So you get a lot more density of containers on a piece of physical hardware compared to virtual machines because you don't have the overhead of a virtual machine. What's the difference? Well, let's take a look at that. So let's go to the most famous, what they call container repository in the world. I'm going to just a word of caution, and you're going to hear me caution this a lot, right? We're going to go look at hub.docker.com, which I'm sure most of you have been on. Do not download anything other than the official images, and certainly don't use the official images internally. Anything that comes from this site must be security scanned and must be scrubbed before it's used, just because even the public images have had their occasional problem. I don't want to create fear, uncertainty, and doubt, but I want you to be smart and cautious. So if you're using this for your local projects, only use the official images. If you have a scanner like Aqua or Twistlock, which we'll talk about in a second, maybe, actually it might be tomorrow, just know that you want that, right? And better yet, if you need to do something, just grab the official repository that your infrastructure team is providing to you. Your team probably has an official Docker repo that you can connect to that will provide scrubbed and officially cleaned images for you. Please do that. But if you're working on your own, you're messing around, please only use the official images here. How likely am I to recommend Docker to a coworker? I don't know. It's pretty good. No. All right. So I'm actually logged in currently, right? With what my son nicknames me Spartan Sage. So DockerCon Live. Oh, interesting. So anyway, I'm already actually logged in. This is the most popular repo in the forum. How many of you have been here before, by the way? Okay, cool. So this is hub.docker.com. When you actually just download an image, which we're going to get to in the lab and some other pieces, when you don't specify where you're going to pull from, it pulls from hub.docker.com. You got to remember that, because that's probably not what you want if you're running things in production. So you need to make sure, and we'll talk about how to specify a URL in your deployment files. But this is where you find like content, for example. Like let's say that you have a thing for Redis, which is an in-memory database, right? Notice that this like says official image up here on the right-hand side. This little like tag star, right? So this means this is an official image according to Docker and Redis. They verified each other, right? Look at all these. There's a PowerPC architecture. There's an IBM. There's a MIPS architecture. I haven't seen MIPS in forever. There's your standard x86 64. There's ARM 64, ARM 32-bit, right? And what these are is that these are like potential tags, for example. So, oops, sorry, didn't mean to like jump over to that. If you come in here and click tags, you can always get latest, but you may already be aware of this, and this might be your first like official like practice. Always specify a version if you're downloading something that you're actually going to be messing with. Try not to always grab latest, because latest is a moving target, right? And if you don't specify, so for example, see this right here where it says Docker pull Redis. This is true, by the way, in Kubernetes as well as Docker. If you don't put a colon and a tag number after that, Redis, you're pulling latest by default. Don't always pull latest. Latest is a moving target. That means every time they do a release, you're going to get a new version. If you're always getting a new version, guess what? It's really hard to test because things are going to break. They will break. It just happens, right? So try to like pin a specific version. By the way, you might notice that there's some Alpine woven into these particular tags. Alpine is a slim, small footprint OS that people have been sticking inside of containers just to make sure they can have things like troubleshooting tools and other binaries used for like logging and stuff like that, right? Alpine is purpose built for containers. It's a very small, slim operating system. It's not based on any of the other popular systems. So it's really thin. So the latest of Redis right now is 621-Buster, right? Here's an Alpine version. Here's just the straight 621, which has no OS inside of it, just Redis, right? And if we look at 621, this is an image. So think of the image as a bootable version of the container, right? That's all it is. When an image is running, it's a running container. But when you download it, you're just getting the bootable copy. You're downloading in a sense like the boot drive, right? You're downloading a bootable container. In this case, it's Redis 6.2.1. By the way, notice that it shows you how this thing was built. From a security perspective, it's good to look at this, right? You can also find out like, where is it getting like the Redis downloads and other pieces like that. This may not be what you want, right? So if you're ever like a little sensitive about like what's inside of it, you can always go take a look and see what's inside of what's called the Docker file. This shows step by step how this system was built, right? Now you can download this container and you can peel back its Docker file if you want to and see. But notice it's setting some environment variables and there's some additional command structures in here. You can actually peel back when you actually download the container, or you can just grab the Docker file. So this is, you can then pick your OS architecture and download exactly what you're looking for, like AMD 64 in this particular case. Look at these sizes, by the way. Is that smaller than a virtual machine? I'm gonna blow this up so you can see it better. 36.83 megs. That's pretty tiny, isn't it? I don't know when the last time any of you have installed an operating system, but they used to take a couple gigs still, even now, right? If we go take a look, let me pick something that might have a Windows flavor to it. Let's say, that's the Linux version. How about, let's take a look. Interesting. Let's take a look at the resources here. Oh, there's nothing. Oh, that's not a good example. Let's pick a better one. Let's pick another kind of like, where's there a Windows? Let's try MySQL, or assuming I could actually spell MySQL correctly. Let's try MySQL. All right, so MySQL, I believe they might have a Windows version in here, but I think the main thing I wanted to point out is that MySQL 8.023, here's 8. Notice these sizes over on the right-hand side, 151 megs. Right? That's pretty tiny. Notice we got the previous version, still pretty tiny, right? These are all, by the way, all Linux AMD 64. So this is not going to run on Windows. So if you decide to use your native Windows containerization system, right? It's not going to work, right? This is actually built for Linux AMD 64. So something to keep in mind as you're looking at these architectures. For the most part, if you're running on Linux, you're going to be fine. If you're running on another processor architecture, like for example, Apple just released their M1 series, right? And when everyone have any one of the new Macs with a new processor in it, I hear they're amazing, by the way, if you haven't heard of this, but they released obviously with a new processor. By the way, they still run stuff inside of virtual machines on these new M1s because people haven't built containers for these M1s yet. So the container and flavor of your architecture makes a huge difference. But the main point in coming here was to show you the size, these tiny little sizes now for these binaries. These containers are small. If I throw an operating system in here, this is going to grow to gigs in size. That was the main point of coming here. We're going to come revisit hub.docker.com more. But notice like just this simple command just to pull down MySQL. Again, word of caution. If you don't put a colon after this with a version number, you're downloading latest. I would much prefer that you add a 8.0 tag, which we're going to cover again when we get to the labs. Okay. So do your best. Yes.
Question. So you say not to do the colon latest. This feels contrary to like best security practice. if you're not pulling the latest version, then you'd have to be making sure you're tracking when new versions are released to upgrade to. I understand the trade-off of like this might break something if you upgrade to the latest new and tested that. Is there any kind of like management tooling or any features of Kubernetes that can kind of help mitigate the risk if you were to do latest on your or either Docker or Kubernetes or whatever to help you be able to roll back to the previous version? If
Actually,
you did break?
yes. Yeah, you
Okay.
can. You can do a rollback easily, actually, especially upon failure. And actually that will happen automatically if you roll something out and it kind of fails. You can actually set a policy that says roll back if it fails. My word of caution around pulling latest is if you pull from hub.docker.com. If you're running your own internal repository that has like security scans and meets best practice, by all means pull from latest, actually. But most operations teams will not even allow you to run latest, actually. And just so you know, like for Elasticsearch and a couple other of the things, they don't even have a latest tag because they don't want people to run latest because of it causing breaks and actually in some cases exposing security flaws they didn't know about. But to your point, Tom, if you're running your own internal repository, there's nothing wrong with using latest actually, because you know that's been scanned, someone's looked at it, it's already been verified and tested before it's actually been put in the repository. The catch though is pulling it from public, because while it's true you could get the latest security patches, you'll also get the latest security holes as well, right?
Okay.
Yeah, but if it's internal, go for it. Use latest. That sounds great. And again, you can set policies that say, hey, if you roll this out, roll back if it doesn't work anymore. Roll back to the latest version. So not an issue at all. Kubernetes means its own version of software independent of the version it's pulling down from your repository. So deployments by any change to a deployment is automatically versioned, which you'll see when we get to deployments.
Would so if you use the latest, would it have something to roll back to?
Well, that's my point, is that it's going to keep its own snapshot. Kubernetes is going to keep its own snapshot of the
images. Okay.
It's going to roll back to the
Got
previous version. Yeah.
Okay, cool.
Yeah. Yeah. So Kubernetes, by the way, by default has to have access to a repository, but it will also maintain its own local cache of everything it downloads, which is another reason that we're thankful these things are small. Can you imagine 100 4 gig images sitting in memory? That's not going to happen, right? Good question. All right. Let's see. We talked about containerization at a high level already. By the way, containers typically boot in seconds. They typically boot in seconds. It's going to take you at least 30 seconds, most of the time 5 minutes to boot an operating system. Amazon the other day, by the way, I watched them boot an operating system in about 5 seconds. It kind of blew my mind a little bit. I was like, oh, this will take a minute or two. Let's come back. Next thing you know, it's up in 5 seconds. That's the atypical, by the way. I don't know what Amazon's doing to get that to work. Operating system perspective, when we talk about containers versus virtual machines, containers are always faster if you talk about the same sets of software. So overall, you get a cheaper, more lightweight, more cost-efficient system when you use containerization, but it's going to be more complex, right? And I will say this, is that Kubernetes was not designed great for multi-tenancy. I'm sure the CNCF would shoot me for saying that, but most people agree in my industry that like, Kubernetes wasn't really designed. They've added stuff on to make it great for multi-tenancy. So, you know, you do have to like kind of configure it a little bit more in order to kind of make it so that it's secure from a multi-tenant perspective. You have to think about it. You have to be intentional. Let's see, containerization. So there's a couple of like, a lot of like variants out there as far as containerization systems. Moby is the open source version of Docker. Creo is the official, CNCF version. Containerd, it's another version. Rocket is another version of containerization. I'm trying to think of others. There's actually a lot. So OpenVZ and LXC and Linux vServer and all that. I mean, those have kind of fallen a little bit more out of favor. They're not as popular now, especially now that Kubernetes. And then non-Linux system containerization systems like Solaris Zones and AIX workloads and all that, That is actually technically true. Nobody's using those. Just to say this, I mean, we use jails like BSD jails like 20 years ago, but I mean, we're not predominantly using those now. People are using Linux with Kubernetes or some flavor thereof, right? Kubernetes is the predominant container orchestrator now. But Solaris, by the way, was the first to actually make it widely available outside of FreeBSD. I actually used to work as a Sun engineer, and Sun Solaris was actually the first time containers were used widely in a production Unix. But Docker really made it super popular. Okay. Linux containers. So basically LXC is a flavor of a containerization system designed to run containers on a single host. Yeah, just to basically know that this is prior art. This is the history of Kubernetes, right? It's just know that it exists. Mainly this isn't used now. Containerization is now built into most modern Linux kernels. You just need a translation layer like a Docker D or some other kind of daemon running in the background that can translate your container system, right? So Docker, such an interesting company, right? Docker was the first to actually package everything together in a way that made Docker like containerization palatable. What do I mean by that? Did anyone even know that they didn't like taxis until like Uber came out? I mean, to be frank, I think Uber is kind of like a horrible company and they've had a lot of bad practices, but they were the first to kind of like make it so that we like didn't realize that we had a thing for taxis. We don't like taxis, right? We don't like paying for taxi. We didn't like it, but then all of a sudden we could get into cars with strangers, right? Which is a little weird in and of itself. But now we feel more secure because everybody's information is tracked, and so at least if they, kill us or do whatever, we now have a history with the person in question, right? I'm kind of joking. I take Lyft all the time, but like this is what Docker did for us, right? Docker just made it easy for us to do containerization, and we didn't even know that we wanted it until we realized that we could get something smaller than a virtual machine. And then all of a sudden we're like, oh yeah, no, I definitely want. Like I'm definitely looking at this point for containers because I want something smaller than a virtual machine. I want to run it in my local environment. I want to be able to give it to Greg, and Greg can run it in Tom's environment, and Tom doesn't have any complaints because all the environmental factors are there, right? And so Docker really just put containerization on the landscape, right? It is written in Go, which is what most of the kind of low latency, high performing services are written in nowadays. Go is like the thing, Kubernetes is written in Go, Docker's written in Go, Golang, right? So just note that in order for this to function, when you run containers on an operating system, just with Docker, for example, you actually have a Docker daemon running in the background who's acting as a translation layer between your commands and what's actually running in the containerization slices, right? So, yeah, maybe not take everything Greg hands you just at face value. Maybe run a scanner or two first. I'm just saying. So Docker is like the kind of like was the one that put everything on the roadmap. But I just want to tell you this is that Docker has fallen a little out of favor. They sold Docker Swarm off to a company called Mirantis. So their Docker Enterprise solution is now owned by somebody else. And while Docker Compose is still somewhat a viable multi-orchestrator, most people are just looking at Kubernetes now to do all that because you can now run Kubernetes really easy locally on your system. So I don't think Docker is going to fail. They're not going to go away as a company, but now they're just one among a series of competing containerization systems that you can now use to run on Kubernetes. As a matter of fact, as of 1.20, Kubernetes doesn't even natively support Docker anymore. There used to be a shim that they ran, they got rid of it. But it doesn't mean you can't run Docker containers. It just means that they're now running through an OCI compliant interface. So they've added a new standard that everyone's following that's been around for a couple of years. So OpenVZ is just a Linux OS level virtualization tech that basically allows you to, run, it's similar to the original Solaris BSD jails and zones. Again, just know that this is all history, right, for Kubernetes. All right. Now, because of the complexity of running so many containers, which is typically what you get, right? running hundreds, if not thousands of containers in production. Google, because of their projects, Borg or 7 of 9 project, depending on what you talk about, they were obviously Star Trek fans, released basically Kubernetes out to the public. This was now consumed by the CNCF, which is the Cloud Native Computing Foundation. At the time, about 5 years ago, when Kubernetes first came out, there was fierce competition between Docker Swarm, Kubernetes, and then this thing called Mesos and Marathon, which is basically, and Nomad, which are all vying to be the dominant container orchestrator in the ecosystem. I didn't realize there was like a kind of a war going on, but basically Kubernetes won the war. Kubernetes is now the de facto container orchestrator for practically everybody. Every single cloud provider that I know of has a Kubernetes installation. Kubernetes is the thing everybody's talking about. No one talks about Docker Swarm hardly at all, even though it's now owned by Mirantis. Mesos, Marathon, and Nomad are considered to be distant third parties around container orchestration. Everybody's running either OpenShift with Kubernetes at its core, or Rancher at its core, or a managed cloud service with Kubernetes at its core. That's where everybody's going. And I don't know, there's a lot of substance to this, but there's a lot of hype to the Kubernetes train. And the hype is dipped down. And now what we're seeing now is actually real adoption of Kubernetes as the de facto container orchestration system. The default website for Kubernetes is kubernetes.io. And this is where you can go to, get more detail about production grade container orchestration, particularly documentation and their blog, which is awesome. If you're not like doing an RSS feed against their blog, I highly recommend it. Because it will basically keep you up to date about anything, including alerts or new features or pending anything inside Kubernetes. I try to make it a daily, if not weekly practice to go through this just to see if there's anything of interest around this, right? Including like the new 1.20, the 1.20 release, any new features. I don't know about it being the raddest released, but it's there just in case. Oh yeah, and this one about the Docker shim deprecation that you just heard me talk about, where it's no longer has its own specialized conversion so that Docker can run natively inside of Kubernetes. Just like everybody else, Docker now has to use the standard interfaces, right? So this is the official website for Kubernetes. I will tell you that their documentation is solid. Sounds like most of you have been there already to a certain degree. But there's lots of like great examples. Some of them are a little dated. They could be updated a little bit, but for the most part, it's great. And setting up a tool natively, like using like plain Kubernetes, the kubeadmin tool is probably one of the best ones to use. We'll talk about that when we get to the last day, when we get to high available installations. There are tons of tools to install Kubernetes. We're going to talk about the different flavors and variants there. Docker Swarm, as I mentioned before, is now owned by a third party, and these are actually still in existence. But Kubernetes is pretty much king, queen, whatever you want to call it at this point. Docker Swarm, it's here if you want to read it. We're not going to spend any time touching anything around it. But this was the old tool that people would use prior to Kubernetes coming onto the scene, and it got replaced. That's what you need to know. Kubernetes itself, I just talked about, right? Just got released within the last 6 years, I guess 6 or 7 years now, because it's 2021, right? This is the de facto way of doing container deployments, and it probably will be the de facto way until the next disruptive technology comes along over the next 5 to 10 years. We're estimating now that pretty much every single deployment that we're doing now will actually be Kubernetes based in the next 5 to 6 years, with some legacy virtual machine stuff lingering, right? Mainly for those applications that aren't making the migration. If you see the word minions in here, by the way, I want you to replace that with nodes. No one refers to it as minions anymore. That's an old term, right? So nodes, right, are basically the application nodes that run the actual containers that are running inside Kubernetes. The rest of this, as far as like replica sets, labels, services, pods, deployments is another piece, right? And masters, those are still current labels. Some of that's in transition because the community is trying to figure out how to modernize some of these terms. And then Mesos and Marathon, just know that these are just historical ways of running containerization. They predate Kubernetes. These are pretty much distant third parties now. Kubernetes is king or queen. All right. I'm not Docker use cases. We're going to skip that for the time being. Microservices. So one thing to note is that the traditional triple tier application of a web tier, an app tier, and then a database tier, that's traditionally how we have run our applications when we run them on virtual machines. And in that app tier in particular, you'll find tons of business logic. Everything from like credit card profiles to like inventory management to whatever, right? Microservices changes that and says, hey, by the way, each of those business concerns you have, whether it's credit card information or the customer profile or inventory management or streaming videos or whatever, let's actually run those in the individual services. And it's a architectural style called microservices. It's super popular right now. There's actually a great website by a gentleman named Martin Fowler, which I'm actually going to post in chat, who is a contemporary over at ThoughtWorks. And Martin publishes a lot of interesting thought, like this is how to think about microservices, but it's an architectural style that pairs very nicely with containerization. The days of running a hugely massive monolithic application in a single like space, people have gotten away from that. Companies like LinkedIn, Google, right, Facebook have taught us that if you want your applications to scale, you want to run them as microservices because then you can horizontally scale layers without over provisioning because of the inefficiency of running in a monolith. So just something to keep in mind is that microservices are an architectural style that pair very nicely. It's like peanut butter and chocolate, if you like Reese's cups, coming together, right? Containerization and microservices are, one's a style and one's a technology. They pair together very nicely. And so if you are using, especially if you're doing greenfield application deployment, make sure that you are doing microservices architectural style, because a monolith isn't going to fit very well inside of a container. What's a monolith? How do you define the boundaries of a monolith? Well, basically, if your system's running, I would say in the like 8 to 12 gigabyte range or smaller from a memory resident footprint experience, you're probably okay. If you're running, like I had someone approach me the other day and they have a 128 gig memory resident application they want to stick in a container, that's a little large. It's not that there's a threshold. It's not like if Janelle came to me and said, hey, I want to run a 64 gig container, I'd be like, oh, you can't do that. She might have, like, Janelle might have a perfectly valid reason for doing that. It might be fine, right? But then, Danny might come to me and say, hey, I've got an 8 gig container. Oh, but by the way, all the application logic is there. And I might be like, well, Danny, you might want to think about separating that out so that the business has separate services for that instead of running everything centralized. So it's not like you have to get all hung up on the size, whether it's disk size or memory size or whatnot, but whether or not the application is handling a business concern or all of the business's concerns. That's the difference between a monolithic architecture versus a microservice architecture where you're separating all the business concerns into individual services, right? So, by the way, microservices usually communicate with a lightweight API interface. That's how they usually talk to each other. So containers go really well with this because you are taking a big application, like a big Java app, and you're separating it into smaller Java apps that now can independently scale from each other. By the way, they can also be independently released, which is really awesome. If your credit card team wants to release an update to the credit card service, they can do so independently because that's the very definition of a microservice, is that that team can deploy, and as long as they don't break the API around the credit card service, they can deploy things. Same with the billing service, same with the presentation service, same with the user authentication service, same with the video streaming service. These now all run as independent containers in their own individual services. They can scale up and down and be deployed independently. So Kubernetes allows for the easy deployment and management of individual as well as clusters of these containers, right? So, and Kubernetes has an orchestration system, is declarative. You just tell it how many of these systems you want. So if Greg says, look, I'm responsible for credit card billing, I need 7 of my instances running it every time, and Tom says, you know what, I've got customer profile and I need 20 of these to run at any given time because people are running it, they can set up independent deployments and Kubernetes will manage them separately and they'll scale them independently, making sure that things can talk to each other and find each other as they need to. Because one thing that Kubernetes does that's also really cool is it allows you to discover what other services are running on a cluster if you allow it, right? So you have to say, hey, you're allowed to discover. So Greg's, customer credit card piece can be easily discovered by Tom's customer profile piece just by enabling service discovery between the instances. So it works really well with microservices because it does service discovery, auto healing, scaling, and enforcement, like performance enforcement. So microservices containers go together really well. So this is not a microservices class. If you want more, I definitely recommend you either read Running Microservices in Production or take a look at that website around microservices. But it is an architectural style that is important if you are doing basically greenfield, brand new application development in Kubernetes, or sorry, with Kubernetes. Okay. All right. We covered a lot of ground. We kind of went just at least at front a little bit all over the place from a context and a broad perspective, just talking in general about virtualization, in general about containerization, in general about container orchestrators and other orchestrators that are out there in the landscape. We didn't necessarily cover Docker use cases, but we did talk about how microservices in particular is a strong architectural style that works really well with containers. The reason we didn't talk about Docker use cases is that the only limitation about when you would and would not use Docker today is whether you're comfortable using Docker. And don't get me wrong, if you have a monolith, you might not use Docker because that architecture style doesn't fit. But if you're using microservices, Docker is going to be your use case. If you want a one-off, if you want to run MySQL or Redis or some other piece of software, really there are no limitations today around Docker or containerization for you to run anything you want inside of containers. Even my use case earlier, like someone approached me and said, I want to run a 128 gig memory resident application inside a container. They can actually run it inside a container. It's just not a good practice to do so. But there's no technical limitation. It's just, that's a horrible beast to manage. Can you imagine having 10 of those 128 gig containers running simultaneously? What host is going to have enough memory to handle that more than one or two on a scaled basis? Is that horrible? No, we can figure it out. There's hosts out there, like on Amazon right now, you can go spin up a host that has 24 terabytes of memory. Right? So it's not like memory is a problem, right? But there are really almost no use cases today that you cannot stick inside of a container if you wanted to. The only is convention. Does it make sense to do so? What are your benefits? What do you gain? Okay. Okay. Questions?
Just one quick question. You talked about Kubernetes allowing discovery of other services. Will that be in any of the labs, or can you go into more detail about that later?
It won't be in any of the labs. I can definitely go into more detail about service discovery later, about one of the benefits of it, right?
Okay, great,
Yeah,
thank you.
yeah. Unfortunately, I do have a small lab linking Docker to Docker, but it doesn't use Kubernetes service discovery to do it. Service discovery is a relatively advanced topic, but I'll make sure that you have plenty of information on it.
Okay, great, thanks.
Yeah. All right. So we're going to dive into Docker a little bit more, but it's actually a good time to take a break because we've been here for about 90 minutes. We usually take a minimum of 15, 20-minute breaks. So let's take a 20-minute break for our first break today. It's 10 o'clock right now. Come back at 10:20. I'll put a timer up just in case you forget. Go take a break. We'll be back in 20 minutes. Okay. So Docker is open source. It's based on existing technologies, right? So Docker is based on mainly what they call control groups, or C groups is the short name, and namespaces, and kind of the linkage between those two different core technologies. If you really want to know, right, how these function, you're going to want to get familiar with how C groups and namespaces function. Namespaces, by the way, is a core methodology inside of Kubernetes. So you'll actually see that has something you can manage. Control groups, you don't see that as often as something you manage, but it's basically about making sure that you set processes in certain sets of what they call control groups, so they get isolated sets of resources and can't see each other. So it's an extension on the jailing concept. The concept of containerization came from the jailing concept, and Docker was the first one to really package that so that it was smooth and easy to use. So I mentioned before that Docker can run on any distribution where you have Docker and a similar processor architecture or an interpreter for the system in question, right? Here's a little bit of a word of caution. For those of you running Windows, if you decide to natively install what they call Docker on Windows, which is a tool that Docker will provide for you, it will actually enable Hyper-V, which if you're using VirtualBox or any other kind of type, sorry, my brain just stopped working. I think it's a type 2 hypervisor, then it's gonna disable that functionality for you. It'll only allow you to now run stuff in Windows. If you're on OS 10 or a base BSD Linux system, don't worry about any of this. But I just want you to know that if you decide to run Docker on Windows, not using Docker machine, Docker on Windows, then it's going to require Hyper-V. Docker machine, by the way, does not require Hyper-V. So that's actually a mistake in the documentation. So, but you can install it natively on Windows and it uses Docker on Windows. What does that look like? Well, assuming I can get to my right browser. So Docker desktop for Windows, which that's the user manual, right? This is Docker desktop. Actually, there's a better link. There we go. So Docker desktop on Windows, if you're using Chocolatey or Brew or anything like that, you can actually install it natively. But Chocolatey, by the way, is great for Windows. If you're not familiar with Chocolatey for Windows, you should definitely get familiar because that's a great way to download open source tools that are kind of scanned embedded, right? And then when you install it, it basically is going to run Kubernetes. You have an option to do a checkbox in the background to get Kubernetes as your backend system. So I just want to mention that is that if you do decide to go this route, right, you can basically enable Kubernetes on the back end, but it will disable your ability to run any other virtualization system. For me, because I actually do use VirtualBox still on occasion, I'm gonna blow this up so you can see it better. Can everyone see my screen? Got a little terminal open, right? So I am using Minikube. Just to say this, if you are using Minikube and you're like, well, how do I get a Docker environment with Minikube? Just to mention this fun little fact, right? Minikube, the way Minikube functions is if you open VirtualBox, it runs VirtualBox systems in the background. So you notice I got a bunch of like, ooh, that's weird. One of my desktops aborted. Anyway, see how Minikube is powered off? It's really tiny there. Unfortunately, VirtualBox does not scale with screens, so I can't blow it up to make it bigger. But Minikube right here is actually powered off. It runs a Linux virtual machine in the background. You're going to see this, by the way, when you run things in the lab. And let me get all this off the screen. But if you run a Minikube status, you can see that nothing's running right now. So I'm just going to do a Minikube start. The main reason for me, though, coming here to show you this is that if I open up another git bash and blow that up, so we're going to let that run in the background. What you might find is that, see, Docker, by the way, has a command. It's not going to work because it's actually not connected to anything. The command line is there, but it's not connected to a Docker daemon. If you're running Docker on Windows or Docker for Mac, Docker for Windows, Docker for Mac, this is all handled for you automatically. And you just need to go into settings and change it to Kubernetes, and this is done for you. If you're using Docker machine or Minikube, you will have to probably set this up yourself. How many, by the way, are running Docker machine? Good. How many of you are using Minikube? No? How many of you using Docker for Windows or Docker for Mac? Oh, now I'm fascinated. So, okay, so here's a question. How are you running Docker or how are you running Kubernetes? Are you running it on another system? Are you allowed to say? Oh, you're on Linux. So you're all on Linux native systems? Oh, that's so smart. Wish I could get away with that. Too many Windows natives tools. All right, so you're running in a Linux virtual machine. Okay, good. Okay, so that's definitely a great way because most of the time you're going to be managing a Linux system, so that's not an issue. Just so you know, if you let me just switch to my other window. So if you decide to run it Minikube, it actually runs a Linux system, which you can actually SSH into. So now I'm on my Minikube system, right? So just so you know, you can do that. I also run an Ubuntu instance that also has Kubernetes and Docker Minikube basically on it running separately just because I like messing with Ubuntu also. The main thing though I wanted to show you here was that notice that the Docker command is not working, right? If you want one system to run Docker and to run your Kubernetes system, because this is about Docker, right? We get to Kubernetes later. We got plenty of time for that. But what happened is that you would just run Minikube Docker env, and it will tell you the command that you need to run, which is just this little simple command right here to basically, to basically make it so that Docker will work. Boom. Docker PS works now, doesn't it? Before it was saying I couldn't connect to anything, but the Docker command now functions. And by the way, the reason you see a bunch of stuff on the screen is it's showing you all of the Kate's, the Kubernetes stuff it needs to run in order to run Kubernetes on that machine. But if I want to do a, let's see. Docker run Nginx, it's just that simple, right? It's now running actually on the system in question. Now, I didn't run that in detached mode, so it's dominating my profile. But now if I do a Docker PS and I scroll up, I should see an Nginx container running right here. By the way, notice that it is stopped, should be stopped. Okay. So that's an easy way, by the way, if you are running Minikube to manage that whole thing. If you're running Ubuntu in a virtual machine and doing that natively, awesome, but just know that you can actually run it natively on your local operating system. I actually prefer running it inside Ubuntu in a virtual machine method, but I show this because people do use Docker for Windows, they use Docker for Mac, and they use Docker Machine and Minikube as localized services to run stuff. Okay, cool. All right. So Docker can be installed natively on Windows using Docker Machine or Minikube or Docker for Windows. Docker for Windows requires Hyper-V. Your installation is going to vary. I would actually recommend actually reading the installation documentation. You can install in these methods, but I would just highly recommend that you actually just go to installing Windows on like go to the Docker like documentation if that's what you're looking for. Again, remember Docker Machine or Minikube are great fallbacks if you want to retain virtualization on your system and you're running Windows. Docker Toolbox, by the way, is also an older way also that you could install Docker on your system. Again, most people now are either running it in a virtual machine or they are using Docker for Windows or Docker for Mac. Now, because you have images that you download, which are then run, right? And those are containers. You get to do stuff like build images that you can run yourself. You can start or stop containers, right? I could run in something detached and then stop it and start it. You can list containers, which is what you actually just saw me do earlier, right? And you can remove a container, right? So earlier when you saw me on the system, first of all, there's a lot of stuff there, right? But if you saw me doing a Docker PS, right? Let's say I just wanted to grep for Nginx because I often fall back to standard Unix commands instead of peeling things back. Notice that here we've got an entry point here that's been up for like where it's got this particular randomized name. And there's also a container ID, right? So I can actually Docker, right? Remove, let's say angry underscore gold. That's one way I could refer to it because that's what's up here, right? Or I could refer to it by the container ID and say, look, I actually want to use the full ID. And you can use shorthand in some cases and just like not necessarily type the whole thing. But notice it stopped me from removing it because it's actually running. This container is actually up and running right now. It's been up for 2 minutes. So in that case, I would do a Docker stop. And then this time I'm going to use the short name that I have for it. And it stopped it. Now, if I go back and try to remove it, and this time I'm just going to use the container ID, although I could actually use the same name just to make sure things are not confusing, right? Now, if I go back and I run that same command, notice that I only have one Nginx running. This other one is gone. Right? If I want to remove or stop the other one, I would just use the same command. So you can start them, you can stop them, right? You can remove them, right? You can attach to them, you can exec commands inside of them. You can do kinds of stuff. Don't worry, we're going to get into that. We're going to get into stuff like that. By the way, there's also a whole set of things where if I want to see what images I've downloaded, first of all, that's a lot to look at. So let me clear that and run that again, right? This shows all the images that I have downloaded and run on my system. Wow, some of these are from months ago, right? Oh, interesting. This is a brand new system for me, by the way. So it'd be interesting. It shows 14 months ago. I don't even think I had this box 14 months ago. Notice here, by the way, is that you see 3 with the same name, but look at the tags. 2 of them have none. One of them has latest, right? These are probably custom ones that I built. Notice the Jenkins, the tags here. So tags, by the way, are the things like if I was doing a Docker run, see everything after that colon? That's a tag. If I type in latest, that's a tag. If I type in, what's the version up there? 2.263.4, if I remember correctly, that's a tag. Tags are what come after the colon when you are asking for an image. When you ask for an image, that's what comes after the colon. How do you find these tags? Well, I think I'm still logged into hub.docker.com. If I run a search, for example, and let's say that Jeff is like, you know what, Michael, I really love Postgres. It's my favorite database, right? I just ran a Docker search, Postgres. What this is doing is it's, first of all, giving me all of the user ones. What did I say about these? In general, don't run them unless you know exactly who this is. Like, for example, I know who Bitnami is. They're a company that specializes in Kubernetes, right? I know who they are. I probably would go and look at their Docker site just to make sure it was legit and was official and blah, 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 blah. But honestly, I'd probably just run Postgres at this point in time, right? And so I could Docker pull. Actually, let me show that again just to make that clear. So I'm going to pull this one. So what am I going to do to grab that image? I'm just going to run Docker pull Postgres. What happens, by the way, if I don't put a tag after this? What version is it running? Someone type that in chat for me. Anyone know what version of Postgres I'm going to pull? Yeah, Tom, latest, right? So I pull this. Notice it said the default tag. I know that went by really fast. It said the default tag was latest up here. So that, just to show you, was the same as if I had done this. Notice it didn't pull anything down. You know why? Because I already ran that command. I just didn't do it with that tag on it. Where is it pulling this from? Does anyone remember where I'm grabbing all this from? That's right. Hub.docker.com, Docker Hub. So if I go out here and I look for Postgres, here's the official, there's the beautiful little elephant Postgres, right? If I go out here and look at tags, it's pulling the latest. Hello, latest. Where did you go? Here it is. First 3 days ago, right? It's pulling this latest tag. Now I can specify a version also, right? So let's say I want 9.6.21. We're back in the command line, right? I already just finished this command. What do I do? 9.6.21. Guess what? Now I'm pulling down 9.6.21. How do you know? Well, when this pull finishes, if I run Docker images, look at this, 9.6.21. Now, are these running on my system? Yes or no? No, they're not running on my system. All I did was pull down the bootable container images. That's all I did, as I just pulled down the images. I'm not running these. That Docker images command just lists out all the images that I have saved and cached on my system. That's all this is. These are things I could run. If I want to see exactly what I am running, that's the Docker PS command that you saw earlier. Whoa, that's a lot of stuff, right? Can I pipe that to more? No, I can't because I'm going to get bashed. That's right. How about this? About less. That's what I'm running. That's what I'm actually running, right? So the only thing I really recognize like right off the bat is the fact that I have Nginx, Jenkins, right? And there looks to be a bunch of like other Kubernetes stuff on here. That's it. Let's see, Mike, you were asking, you said, hey, did OS boxes have that set up already? I don't know if the OS boxes did, but the image was set up with Docker already connected into Kubernetes. Yeah. And so, and I'm just make sure we're clear because obviously it makes a difference. It's Minikube start. I'm assuming that you were referring to, not kubectl start. So, yeah. All right. So Docker is just a way to manipulate these things. And you've got the images section, which is a cache in memory. And then you've got the actual running containers, right? Now, notice that there's a whole like command line reference here. I have to say that I do actually regularly refer to the Docker command line reference. Why? Because they do change things a lot, honestly. They do. It's shocking. I've had flags just change up underneath me, right? It's less of that now. Docker's slowed down a little bit on their deployment. But just know there's a bunch of environment variables you can set, right? I'm going to make sure that this is posted in the chat so you have access to it. This probably looks like an eye chart, by the way, so let's blow that up. But there's things like you can like set, there's like proxy, there's configuration files inside the, it goes through all the like different pieces. But see all this over here, app attach, build, builder, etc., cluster, all that stuff, Docker compose, right? You can also find these just by typing Docker help. And if you want help with a specific one, you can run the Docker command, but this is where it changes, by the way. Let's say that you wanted to know more about help, you would just add a -- help at the end of your command. Being able to know how to find help in your command line tools is probably more important than having the stuff memorized, although you will memorize the most common commands that you use. Stop, start, attach, exec. You'll memorize those as you manipulate them more and more, right? Yeah, and so for example, if I only wanted to show the latest created containers, you go to doc ps-l and it lists like the last thing, right? Which in this case was, looks like a Jenkins CI/CD command that I was running a couple days ago. 13 minutes ago. Oh, probably when I started up the system. That's when it came back up. Okay. Oh, that's an interesting one. Total file sizes. Look at this. 0 bytes, 0 bytes. Interesting. So there's always cool stuff in here to look at. I usually find stuff that they've added to the system by running through the help section on occasion. So remember, Docker help is your friend. That'll give you your base commands. Docker, let's say RM, for example, -- help will give you more information, right? Okay, cool. All right. Docker consists of a couple of components. Of the most important part is probably the Docker daemon. which the API interfaces with, the RESTful API interfaces with through the command line, right? And what happens is that you end up managing containers, which are actually running images, right? Versus data volumes, which volumes are a way to attach storage to Docker. And then of course your network settings are probably the other piece that you manage most closely inside of Docker. So those are the main components. When you run on the left-hand side, these particular pieces, what you see is that when you run Docker build or whatnot, it actually is interacting with the actual Docker daemon, which is then doing the management for you. Notice that there's an external registry over here. So on the third day, I'll show you kind of the setup of my demo cluster, right? Actually, it's on EKS. And so you'll see that it's actually pulling from a third-party repository, not hub.docker.com. So that'll be one of the things that we talk about. But you need a registry to not only just run for your own Docker host, which by the way, that registry could be local, and you need one for Kubernetes as well. Because remember, you got 50 nodes in a cluster. Where are they going to pull their images from, right? Now, again, in most enterprises, that's a private registry. It's not hub.docker.com. It's something like an Artifactory or a Nexus, or even you running your own private registry software where you've got scanned and controlled images. But this model of command line talking to daemon, then managing the resources, pulling from a third-party location to pull at least the bootable copy of those resources, this model applies to Kubernetes as well. The only difference is that Kubernetes has a lot more components into it. And when we get to that, we'll actually talk about the API controller and the cloud controller and all the controllers like the storage controller that are available inside of Kubernetes. But this is for Docker, just that simple. I say just that simple. It's actually really complex, actually, especially when you peel it back. But remember, images are the things you download that are bootable. The containers are the running versions of those images that you have on your system. So again, Docker images are just read-only boot templates. That's all they are. They're based on instructions created in a Docker file. What's a Docker file? Well, Docker files are files that explicitly have the pieces. Like for example, if we go look at Postgres, that contain the explicit things that were used to create the system. So if we're on hub.docker.com, and again, we go back to Postgres, which I'm convinced is Jeff's favorite database. I'm just kidding, Jeff. It might be, I don't know. I'm not knocking it either way. And we go in here and let's say we pick a particular tag. Let's say it's 9.6.2.1. What you'll see is you'll actually see the Docker, the image layers actually that are inside the system, including things that it's exposing, commands that it's running, what its entry point is, right? All pieces that we're going to walk through. I wouldn't say in heavy detail for this particular Docker file, but we'll walk and make our own Docker files so you can actually see what the possibilities are. I will say that single image, like Docker files like this, are relatively rare. Usually a Docker file is based off another image, meaning you might use OpenJDK as your base image, and then you pull that in. So you might have multiple chains of images that you use to create your Docker images, meaning you might source it from someone else's, like security's base image, or operations might have a base image, right? Wherever you get your images from. They might say, if you're going to build a container, you've got to use this as your base image. So if it has a from at the top, it's actually using another source for its base image, like from scratch, for example. So images are based on instructions. By the way, this spelling is actually super important unless you decide to give a flag to your build commands. But this Docker file has to exist in the directory that you decide to run Docker build in, and it has to be spelled with a capital D, right? So you create a Docker file, add instructions to the Docker file, and then build the image, right? And then once the image is built, you can then just run the image, and this creates a running container based on the image. We're actually going to do that in our lab today. By the way, you might say to yourself, Michael, where can I find like good Docker files? Now, again, word of caution, anything you pull off the internet, you need to read, understand, and possibly scrub, right? I know you know all this already. I'm just reinforcing it, right? But let's say we wanted to look on Docker files, right? Oh, there's what I'm looking for. Awesome Docker files. Where was it? I don't know when the last time he has looked at this, but it's a good site to start with. All right, here's some, this hasn't been updated since 2018. This is a while ago, but there are actually still cool Docker files. So if we look in here for Python, let's open up a Docker file. So notice that he's building this from another image. So he's building this image based off of another image. There's danger in that. There's also awesomeness. What's the danger from building off of somebody else's image? Anyone? Yes, I love that. I love that. That's a good just trust in the unknown, because that's what we're talking about, right? Yeah, that's dead on. So, right, because we don't like, if we don't know who built this image or the sourcing, right, we can't trust it. We don't know. And as you probably are well aware, it's really easy to stick malware inside of a system that's really hard to detect, right? If people are like, people are so remarkably innocent about that kind of thing. And I'm like, no. The only way to know if that machine is clean is to nuke it. It's got to go, right? That's not the only way, but it is the simplest way to ensure, right? In that particular case, by the way, you would probably pick a from that would come from your local internal repos, right? You wouldn't pick one from a public. In this case, the guy's picking it from public because he trusts that the Python team didn't care, but we probably wouldn't do that without scanning it, right? Notice it's got a maintainer. And then what port is he basically saying that this thing is going to share out? What port is it listening on? Does anyone know? Can we take a guess? Jeff, that was good. SolarWinds available as a Docker image. Oh, yeah, I bet it definitely is, by the way. Look on hub.docker.com. There's one there. So back to my original question. Yeah, so it's basically it's exposing port 5000, right? Now, env, by the way, just sets environment variables. By the way, how would you know this? Like I'm over here like rattling it off. How would you know, right? Very simple. If you needed to know and you didn't know, right? Is that you would just say, hey, I need the documentation, right? Assuming that Michael could spell documentation correctly for the build command. That's it. Docker build command line reference at docs.docker.com, right? And then you could come in here and you could actually find all the things that you could support has both options for the build command, but also ways to build a Docker file. Oh, wait, I did that wrong, didn't I? Hold on. I'm looking for is Docker file, not build command. Thank you, Docker file reference. So here is where you would find like ways in which you could like run directives for parsing, different syntaxes that you needed to find, how to escape things within the file. Again, it's a lot to read, but notice on the right-hand side, I know this is kind of a big page, so let me blow this up a little bit, that if you're looking for the from directive or the run directive, you could just skip here, command, label, expose. We were just looking at expose, right? This basically says, I want you to listen on a specified network port at runtime. Entry point, right, which is something else that we looked at, has two forms, which is the shell form and the executable form, right? It basically allows you to configure a container that will run as an executable, right? Versus by default, not necessarily running as an executable, but just passively running, you have to invoke it or do something with it, right? So that's how you find the what all this actually means, but we're going to talk about some of it. Some of this you can intuit. This is an environment variable, Python buffered equals 1. Here's the working directory. Here's the entry point, which we just talked about. Teeny, by the way, is kind of like a tiny little supervisor that you can run inside of a system that will help like make sure something runs or doesn't run, or like if it bounces, it'll like restart it and stuff like that. Gunicorn, I'm not really sure I get that, but whatever. This is the command that it runs. If we needed to know what that was, we could click on command, right? In the command line reference, and it basically said that there's only one command instruction in a Docker file. Whichever one you run last is the one that's going to take effect. It is to provide a default action for the container. In other words, if you don't specify it and you don't have a command there, you need to specify a default command that you actually want it to run. If you have a CMD there, this is what it's going to run by default without specifying it. So here we're running a command, so it's going to run his app. Oh, by the way, he is going to copy some files from his local directory into the app directory. Why does that matter? Because that's where the working directory is. And then if any of you have used Alpine before, APK is how basically you add things like packages, certificates, pieces like that. And so actually here, they are updating Teeny and updating CA certificates to the latest version. So if it's not installed, it's going to install it. If it's already installed, it's going to update it. And then he's, if you're familiar with Python, he's installing his requirements. Then he's removing a bunch of cache files. And he's copying everything that's in his current directory into his working directory, which is /app. Now, barring the weird stuff, like entry point and CMD, does this make sense to people? Any part of this is like, Michael, I really went through that kind of fast. I don't really know if I understand that. How many of you have seen this before? How many of you are working with Docker files already? Yeah. Okay. So this is the way the containers are built. By the way, even when you're using containers, even when you're using using containers, or using Kubernetes, you still actually have to build containers. So whether you use Docker to build your containers or something called Podman or Builder, right? Podman, Packer, Builder. Those are all ways in which you can actually build containers. Whether you're using Docker or any of the other three, for example, which I think Packer, for example, uses the others. You're going to need a Docker file, at least for the Docker version of this. And the others, by the way, will also build Docker containers. So learning this format is actually certainly not a waste of time. This is the way most systems are supported. Tommy said, is there any way to knowing what's in app without loading the container, right? Like without loading it down? Yeah, you can actually pull the image down and extract it if you want to, right? So without running it at all, you can actually pull it down, and then it's not really a tarball, but you can actually extract it and list the contents of the directory if you want to. And by the way, you can take any container image and ask it to be extracted as a tarball, and then just unfurl the tarball and see what's in there, right? Which is actually how most tools actually do scanning, is they actually pull it down, unfurl it. So, and then if it's a running scanner, it'll run it, obviously. But they'll pull down and scan the file system, which is a great first start, right? Let's see what's on there. Let's see if there's anything malicious in there, that kind of thing. The only time that becomes a problem is if there's a compiled binary in there. A lot of the scanners will flag it and say, I can't see what this thing actually does, right? So just depends on the language. Okay, so you got a little sample for a Docker file. Don't worry, you're going to be writing your own Docker files. Everything I'm talking about, by the way, you're going to see at least 3 times, probably 5 times. So don't worry, you're going to get your own chance to do this, right? So you're going to do it. You're going to put your hands on it. You're going to see it. You're going to get your chance to mess with it. Okay. All right. Images are read-only templates. We talked about this already. Files. Okay, containers. All right. So containers are just running images. That's all it is. If I pull the image down, it's sitting in memory. It's not running. It's just there. If it's running, then it's a container. So I used to get dinged for this all the time. I used to work with an architect, and I would be like, well, I think we're running those images in production. And he'd be like, do you mean that we're running containers, or that you have the images cached in production? I'd be like, no, we're running the containers in production. But people conflate them all the time, so don't get hung up on that. Just know if they're talking about images, they're talking about the bootable cache. If they're talking about containers, they're probably talking about things running, right? There are a number of different commands that you can run on Docker to both like run it in the foreground or the background of your terminal, right? So that's something to know, is that like when you saw me earlier run the nginx command, it took over my terminal. right? If I wanted to run it detached or in the background, you could actually start it that way by default. If you add an IT or other commands to it, you can actually make it more interactive or less interactive. I just don't want to overwhelm you because I want to get to labs before we like dive into that. You can obviously give the container an easy name if you want to, right? All of which you're going to see in our labs, but I just want you to know that you have tons of options on how you control Docker. One thing to note is like when I ran earlier, again, just to show this, is that when I ran Nginx earlier, it took over, right? Notice I don't have a prompt. It's got my prompt because I'm running it in the foreground. It's taken over. So there's a couple of different things you can do here. I'm going to Control C just to stop it. You could actually do something else if you wanted to. Notice that all my inners are catching up with me, right? And so if we look now at what you can now see the Nginx, we have the old one that's been up for 31 minutes. That's the second one, right? Ignore that one for a second. I actually have that one doing something, but this one is the one that I just started, right? That one took over my foreground, but when I Control C, it didn't kill it. It actually still running in the background, right? If I wanted to do the same thing, but I wanted to run it in detached mode, I just do it, oops, maybe without the slash run. I could run it in detached mode, actually. And notice here that all it is just kicked out a UUI, basically a hash confirmation. And if I do the same thing, notice that I still have my old one that's been running for 32 minutes. I've got the other one, which I just ran a minute ago that I Control C out of. And then I have this one, which is the one I just started, right? So just know running in detached mode is how most of us start containers, is they're detached. Most of the time we run them in attached mode, or we attach to them when we're doing troubleshooting, or we want to see the log files, or we want to see the output. Most of the time we run them in detached mode in production. They're in the background, right? Kubernetes, by the way, handles all this for you. It runs them detached in the background, no issue. And it captures all the log files. Kubernetes captures all the log files by default that are sent to standard error and standard out. So Kubernetes handles a bunch of this for you. But if you're running Docker on your own local system, it's going to run in the foreground unless you give it a -D and say, I want you to run in the background. Okay. All right. What can Docker be integrated with? Like we've got this, like what can you run in Docker? Well, here's the answer to that question. If we look at this file, what would you speculate the answer is that you could integrate in with Docker? What can you run in this file here? You're seeing a Gunicorn for an example, but we could pick anything. Let's pick another example, right? Let's go back and take a look at Java. Let's go look at the Docker file here, right? See this command it's running? Java command? Let me just ask you this. Are these not just command line executions? That's all it is, right? It's not saying I have to run Java or I have to run Go or I have to run Python. So what can you run in a Docker container? Anything that runs on the command line. That's your only limitation. Is if it runs on the command line, it'll run inside of a Docker container. So this whole I get kind of a kick out of this actually. This whole slide, what can it be integrated with? It can be integrated with anything basically that runs on the command line. So if Docker build is your command to run, right? It'll run anything in the command line. So if you invoke, for example, GUI apps on the command line, you can invoke them inside of, right? Docker. It'll expose GUI apps all the day long. I had a buddy who runs VS Code inside of a container and exports it out, which I find hilarious for a variety of reasons. But if it runs on a command line and it started through command line, you can run it inside of a container, which by the way, what process can't be run off command line? Very, very few that I'm aware of, actually. And none that I can rattle off the top of my head. As far as I know, almost all processes now are command line driven. So the only limitation of what you're running here is if something's interactive and requires human input, you're gonna have to do some finagling to get that to run. Otherwise, if it can run without human input, for the most part, It's going to run inside Docker, no issue. Okay. It is worth mentioning that we've got AWS's EKS service, right? Which I think probably most of you are familiar with, which is the Elastic Kubernetes service, right? I'm just going to go after the big three for this. You've got the Azure Kubernetes service, right? That's the other service, the big one, right? And then you've got, of course, Google's Kubernetes engine. Assuming I can spell engine correctly, GKE, right? Azure and AWS in particular have government versions of their stuff, right? They have a government platform like that you can host stuff. So if you're approved for that, EKS, for example, runs in what they call GovCloud on AWS. The Azure Kubernetes service also runs in their version of it, which I am, for some reason, not remembering the name. I don't know if Google has, this is one I'm most efficient in. I don't know if Google has a government version. They might. I don't know if they do or not. But their Kubernetes engine is also a very popular third-party service. There are others out there like Mirantis, which bought Docker Swarm, right? Mirantis has its own private cloud. Well, that's a pretty website, actually. I haven't been there in a second. And then what else? Bitnami, who you heard me talk about before, who does a lot of package applications for cloud. They also host Kubernetes, right? There's a bunch out there. These are like more like hosted services. Obviously, you don't get to pick whoever you want. You get to pick whoever's approved. So you already probably know who your like Kubernetes vendor and or platform is of choice, and you have to stick with it, right? And just so you know, that's not true just for like any kind of government entity. It's also true for, right, the public sector as well. People don't get to choose what they want. They're still limited. OpenStack, Rackspace, IBM has their cloud. Alibaba has a version of it. Everybody's got a version of Kubernetes now. So, by the way, the reason this is appealing to people is that if you can write an application that will run in Kubernetes, you can run that in anywhere that Kubernetes can run. So unless you have a specific requirement for either a service or a piece of hardware, if you write your application to run in Kubernetes, it'll run anywhere these providers run Kubernetes. So there are some limitations on that, right? Because obviously processor architecture, if you have like a specific service that you're tied to, you got to pay attention to that, but you're probably already aware. Okay. Oh, probably worth mentioning that containers by default, the minute you make a change to the Docker file and rebuild it, you get a new version of it. You also tag it with a new version. Typically, you don't overwrite a previous version, you just get a new version automatically, right? You can assemble from a variety of different sources. You know, you could use Packer for that. You can use Maven. It just, again, your limitation is what's on the command line. That's your only limitation. We did talk about hub.docker.com, right? We talked about pulling from official repo. Some cases you do have to provide a login. You probably didn't see that on my part. But I am actually logged in. If you type in Docker login. Oh, hold on. It is going to ask me for like my username and password, right? Which I'm not going to type. So. Right? Some of the images do require you to have a username and password. I haven't figured out when you don't versus you do. I thought it would only be when you push, but sometimes when I actually ask for versions of images, it throws an error message. If I log in, this is something I actually wrote them about this and said, hey, can you tell me what the criteria is? I haven't figured this out yet. Okay, just remember, this is the most popular repository in the world, but you do need a repository to run both Docker on multiple hosts and to run Kubernetes on multiple hosts. So whether you host it or it's a service, just know that you do need one. Okay, so this is interesting, right? Now, instead of just running like Ubuntu or Alpine, we're actually running it with a specific outcome in mind. So Tom, you're asking, can Docker be connected to multiple repos at the same time? I don't know that it can be logged into more than one repo other than hub.docker.com. I don't know the answer to that. I know that you can pull from multiple repos. There's no issue at all for you to pull from multiple repos at all. The login credentials is the one thing that I don't know that I've seen work exceptionally well. Like I have an Artifactory, like a JFrog Artifactory repo. And if I'm logged into that, I seem to have to log back in if I want to pull from hub.docker.com. I don't know if that's the way that Docker does credentialing, but it seems to have some kind of issue with multiple logins. But the documentation says that it can log into multiple systems. So point being, you can pull from any repo you want. All you need to do is specify the URL after the image specification. But the login piece is doesn't act like the way the documentation says it should. So, okay. So on this particular piece, if I do a Docker run and I do Ubuntu, first of all, what's the default tag? Anyone? What's the default tag? Don't specify one. What's it going to say? Latest, right? So this one, I'm actually just going to pull that 20.04, right? And to go back to the command, I'm just going to run the echo command inside of it, right? Just want to echo and just say, you know what? I don't know why yo Docker, but whatever, right? That's all it's going to do. Echo yo Docker. If, by the way, I want to run a shell in there, can I do that? I can't for some reason. Interesting. Why is that? Right? Actually, I'll talk about that in a second, but for some reason it doesn't. This is a problem of running git bash on Windows, is that it's looking for a local system instead of actually running it inside the system. We'll talk about that in a second. Yeah, and I need to basically specify, yep, someone actually beat me to it, Mike. I need to actually specify interaction and run this in a terminal. Otherwise, it's going to try to run something locally, right? So if I do this, right? Oh, and I got to add WinPTY because I'm on Windows, right? But it still throws this weird bash error. So this is something I haven't quite figured out, which is why I prefer to run it in Ubuntu. Sorry, that was a bad example. Notice, by the way, it is specifying that the OCI runtime create failed. What's OCI? Right? That's the Open Container Interface, right? So this is something that is, I think, worth highlighting, is that if you're running a Linux command prompt on side of Windows to try and hook into a Linux box, there's kind of problems there. So I'm glad to hear that you are mostly running Linux and or OS 10, depending on what your preference is, because they tend to handle this native stuff more easily. You'll hear me mention more caveats for Windows and how Windows can handle this more than any other service. So if you're not running Windows, it's easier. It's good. All right. So yeah, WSL. Problem is that WSL does not require Hyper-V, so it disables VirtualBox. So you can't run virtual machines other than in WSL at that point in time. So I'm always thrown by that. Yeah, no, I know. I understand. But like Vagrant doesn't work very well with Hyper-V. It still throws issues. All right. So we touched on some of these commands before. So Docker PS-A, which just shows all the containers in the background, as well as starting a container, specifying the particular ID, right? Inspecting a container, which can be very, very useful, right? So let's say that we wanted to inspect a container and we wanted to do agitated_black, which is that first one. First of all, there's a lot here. First, it's going to show all of the basically JSON defined states that it has, variables as far as like what's its status, you know, is it running, like any current like codes that are running, what image does it use, what's the SHA hash for that, the configuration file for the for DNS, host name, and a bunch of other components. What driver is it using, right? Any host configurations, any volumes that were attached, any other sizes, right? All listed here. So this is great for inspection. And of course, you can stop containers. You can start them, stop them, right? Variations thereof. So, interesting thing about dealing with containers is that they're really great for stateless applications. I'm not saying that you can't run data stores and databases and caches inside of containers, because people do all the time. As a matter of fact, most people run their production workloads, their data stores inside containers inside of Kubernetes. There's no issue with that. That's not a problem, right? The issue is that most of us don't have enough experience to deal with containers and stateful containers. It's just an experience thing. Running state inside of containers requires a new stage of understanding how to maintain state and how to maintain synchronicity between the application that's looking at the state on that volume. Let me say that again. There's a big difference between running a system that's designed to have a hard drive attached to it, like a virtual machine, versus running a container, which has temporary storage that's going to delete as soon as the container fails or stops. Because what you need to do is that you need to actually then create a persistent volume of some type, or a volume, to attach to the container. So if the container goes away, that data doesn't go away. That's the objective, right? If you're running a data store, I don't want to have to reload 10 terabytes of data just because the container had a hiccup, right? So just know, though, that by default, unless you attach a volume, or in Kubernetes attach a persistent volume to a system, which, by the way, could be network file share, it could be direct attached storage, could be iSCSI. If you don't attend to that as a separate thing, by default, when a container fails or is stopped, right? If you destroy a container, not stopped, by the way, if you destroy a container, the data's gone, right? Not stopped, destroy. If you destroy a container, the data's gone. If you stop it, that's just pausing it. It's still good, right? Ideally, though, data is not necessarily stored in containers. It's stored in volumes that are attached to containers, because it uses this layered union file system to create layers for all the changes that you have done to the image. So if you start with a bare Ubuntu and then you update it, you add another layer. How do we know? Well, I think we saw this already. Because when you saw me do a Docker pull, and I did Ubuntu, for example, let's say, let's see, 1804. See all those layers it's pulling down? Not all those layers, like a tremendous amount of layers, right? But it was pulling file system layers. That's a stacked file system, because every line you have in your Docker file that adds data to a container adds a layer to a container. Let's go look at that again, just to make sure that that stays cemented in your head. Assuming I can find the right browser window, right? See this? This is the base image that we're building a container image from. Every time I copy a file into here, or even run one of these tasks that defines this, like a change inside the OS, it's actually adding a layer. It's adding a layer to the system, which is, by the way, you'll find people running these strings of commands on one long command line, because they're trying to minimize the layers in their operating system, right? But you're going to end up with these like layers, and each layer has a little bit of overhead, so it's not like it's that big of a deal, right? But these layers download independently they form like layers of a cake to form the cake of the container, right? They're like little layers of a cake. So you can peel back these images, these layers, if you want to, both by looking at the file itself, but you can also extract this and look at individual layers inside the system. So that's the only way that like data gets persisted is during the build process. After the container is actually launched, any data you stick in that container that doesn't have a volume attached to it, it's lost as soon as the container is destroyed. As soon as it fails, right? If you stop it, it's still there, but otherwise it's gone, right? So you can create Docker volumes to do that, but just to say this, you would only do that on your local system. People don't typically run Docker in production. they'll run Kubernetes maybe with Docker containers in production. But right, you're not gonna like use Docker for that. You're gonna use Kubernetes for that. Where on the host does Docker store the volume? Wherever your default Docker installation is. Typically, if memory serves on like an Ubuntu instance, it would be var lib Docker, if I remember correctly. I could be misquoting that, but it's probably in var lib Docker, which is where Docker sticks pretty much everything, including images, for example. So creating a volume is actually pretty simple, right? You just create the volume there, run the volume, right? With the -v option, which says, hey, this is my mount path. This is an interactive terminal mode. This is Ubuntu 12.04, which is actually a pretty old version. And then this is running bin bash, right? To view the volumes, you just do a Docker volume ls or Docker volume. And then if you want to move a volume, you can. You can also prune them if you want to, which means it will get rid of all unattached volumes that haven't been used, right? Or sorry, that are not currently in use. So this is going to store data in a file on your host system. And you can then mount that volume inside your container definition. So this is one way of persisting data, like if you're running a local Jenkins instance or you're running a Postgres database or an Elasticsearch or a Redis. This is one way you can persist data by attaching a volume to your running container. Now, in your Docker file here, because we touched on Docker files just briefly, here's another version of where we're running from OpenJDK, in this case, latest. We're running based, and it looks like a Debian-based system using apt-get. Debian-based system is probably Ubuntu, because it's not using dpackage. And then we are running an update, installing SQLite, and we are saying a -y because we're just skipping past the confirmation. And then we are copying this jar file into the root directory, simple greeting snapshot.jar. And then once we've got this Docker file defined, we are using a Docker build -t, which is a tag. We're tagging this image, and then notice that period, which says the Docker file is in this directory. Like it's right here, period, this directory, which means current working directory, excuse me. If we don't specify where the file is, or we've changed the name in some form or fashion, we've got to put the -f on there, which is like, here's my Docker file, right? And that's used to ensure that you can like find the file in question. So you could actually like have like a production, staging, dev, like different like versions if you want to. There are better ways to handle that. But like whatever your need is, if you need to have specific like differentiated Docker files in the same project, you could actually. I'd probably be looking at Docker Compose at that point in time if you were looking at that. And by the way, there is Compose with a K, which allows you to run Docker Compose items in a Kubernetes cluster. So if you're interested in that, excuse me, my nose is itching like crazy today. Oh, speaking of Docker Compose, look at that. So most of the commands you see us using are to run a single Docker container, a single container, right? That's what those commands are for. If you need to run a multi-layer container, let's say that you had a web layer, like a web container, an application container, a database container, or a search container. Like if you needed to orchestrate an application that had a bunch of microservices to it, you're probably going to use Docker Compose for that or some variation thereof, right? So Docker's going to run a single application. Docker Compose is going to allow you to at least simply orchestrate a series of containers across the system. It's still limited. So Docker Compose can be extended and jury-rigged to run on other systems. But for the most part, Docker Compose is still intended for one system. If you're going to run it on across like a cluster of systems, right, Kubernetes deployments are still the things to use. So that's what it's for. Compose is just for a tool for defining and running multi-container applications on the same host. So it uses a Docker Compose.yaml or .yaml. It's used to define a group of containers that must be managed as a single entity. Here's an example of a kind of sample Docker Compose YAML refers to an individual Docker file. So here we are defining services. There's two services defined. We've defined a greeting service and we've defined a MongoDB service. Now, notice that it says, where's the build location at? And it says, ooh, right here. Meaning if you're in the wrong directory when you run this, there better be a Docker file in here, right? There should be a Docker file in here. Otherwise, it's not going to know where to run because there's no Docker file different specified, right? It's going to expose this both internally to port 80 and externally on port 8080. Sorry, internally on port 8080, externally on port 8080. And then it's going to link to MongoDB. And then what that means, and by the way, this is the old way of doing it. I think it depends on is the name of the new way of doing it. Depends on links still work, but it'll give you a deprecation error. But MongoDB says, hey, I want you to pull MongoDB, the latest, from hub.docker.com, right? Or whatever the locally specified repository is. You could actually specify a repository name here if you wanted to. And then you're going to set two environment variables, which is the username and password. I just want to say this is not the best practice in the world to stick the username and password inside of a flat file. It would be better to randomize this either by pulling from a secrets vault of some type instead of having this hard coded on the line. Or, I mean, even better would be just specify this on the command line. At least then it wouldn't be in a flat file. Oops, sorry. Went too far ahead. And then, so I probably wouldn't do this, but just as an example, you could, right? You can, again, specify this on command line as well if you want to. And then notice that it's going to mount the data DB volume into a file, a volume file called my volume, which is just defined and located down here. I believe it doesn't have any limitations on it. So it hasn't like specified like a size or anything like that. That volume file can actually grow in proportion to the amount of disk space available on the host. So something to be mindful of or careful of, right? Is that it can eat a bunch of space on the host. Kubernetes handles that a little differently, although at least in the base mechanism works remarkably similar, and that you can actually specify a local file for it and then mount it up into the pod/container where it's running. Most of the time, though, Kubernetes will actually mount a hard drive or a network file share to mount storage instead of mounting it on the local host. The reason that's recommended for Kubernetes is that if you mount a local file, that data is lost if it moves to another host. That file does not get replicated or copied on Kubernetes. Doesn't get replicated or copied on Docker either. So this is really for non-production runs only. Okay. So this allows you, for example, we could put 5 services in here. It doesn't just have to be these two. We could put a web service. We could put an Elasticsearch service. We could put a bunch of orchestration here and say, look, I want MongoDB to start at first, and then Elasticsearch also depends on MongoDB because it needs it to, reference. And then I want, greeting to refer to Elasticsearch, and I want web server to refer to greeting. So you can actually create chains of dependencies if you want to control the order of startup, right? So that way you can make sure that your web service starts up last, database starts up first, application starts in the middle. So again, reminder links is the old way, depends on, I think is the new way, if my memory serves. Okay. YAML, yet another markup language, which I actually prefer, actually. I probably know how to read JSON a lot better because we've been using it for so long, but YAML is pretty cool. The only problem is that when YAML gets special characters in it, you don't have a good linter available. Oh, it gets ugly. It gets ugly when there's a special character in there. What is there to say about Docker? Oh, hold on. Let's go take a look at other Docker Compose files. Oh yeah, because I didn't actually search all the GitHub. Let's switch that. Good. All right, so let's look at some awesome Docker Compose samples, right? So let's pick Flask because I do like Flask actually. All right, this one's pretty simple. I don't know how awesome that is. Why did this thing include in the repo? But basically it says, look, I want you to build a app, right? Which I'm assuming is like locally built of some type. It's just exposing port 5000. Well, that's not like super awesome. Let's look at another awesome compose file. Let's try a Flask MySQL combination. So let's look at this one. So notice the services here. I've got a DB service. Everybody see that? I got a DB service. Then I got a backend service. Then I got a proxy service. Notice that it's got some defined networks and some ports in here. This is Docker Compose, by the way. This is an example Docker Compose. Here's some other networks as far as like I want you to hook into backnet and frontnet. There's some secrets here. That's good. So it's using some defined secrets, which is awesome. No passwords are being defined in the file. Notice it's saying build backend down here and build proxy. Wonder what that refers to. Let's find out here in a second. And then notice that it's actually using the official MySQL image 8.0.19 for the database section. Setting up an authentication plugin. Here's some secrets. Here's a data volume. Oh, there's some environment variables. Not my favorite, right? Would rather set that to a secret or specify it on the command line. That's okay. And then notice the volumes are defined down here, including like, it looks like a DB password file from secrets. I'm not sure why they wouldn't have just done this up here, actually. Oh, wait, they did. There's secrets. Oh, and there's an example. Never mind, it's stand corrected. That actually is not a bad way to do it. All right, so let's take a look in this directory because they referred to proxy and DB. What's inside of these things? So I bet you there's a Docker file here, and look at that. There is a Docker file. So they referred to a directory. So let's go back and look at that again, just to make sure that we're clear about what we were looking at. This is the Docker Compose. So this is used to orchestrate multiple Docker files or Docker containers, right? In this particular case, notice that when they said build, they just referred to the directory. They didn't actually specify like a Docker file or any piece like that. They just said here in this directory. This is where you look for the Docker file. And then if you go back and look at the repo itself and you look inside proxy, you see that there's a Docker file here. And all it's doing is just grabbing Nginx, but it's copying the conf directly from this directory. And it's putting it inside etc nginx conf.d default.conf. That was a pretty fast review. Does that not make sense to anybody? It's pretty basic, right? If we look at that conf file, by the way, it's just saying, hey, I want you to listen on 80 and then I want you to pass it to 5000. Right? Let's go take a look at backend, which it also referred to. Here's another Docker file. If we click this open, right? I've never looked at these before, by the way. So this is like, we're just pulling up random files. Notice that this is using the 3.8 Alpine image. It's setting a working directory. It's copying the requirements.txt. Why? I'm assuming because it wants to make sure that when it runs pip install, the requirements.txt file, which has all of the additional libraries and stuff that it needs for its app, are going to get imported. And it's going to copy everything that's in this directory into the code directory. And then it's setting an environment variable, right? And then it's basically saying, I want you to run. And I want you to listen on every port on the, well, on the stack for the host. And here's a hello py, and here's the requirements file that it just lists Flask, the MySQL connector. And then here's the hello py itself, which is basically just some kind of DB manager. Looks like it's dropping tables and creating tables and doing stuff inside of the MySQL database. Right? Doesn't matter what the Python is, right? But that's an example of a Docker Compose file. The only one that I don't think there was a reference to is like, it's apparently copying, it's mounting this password inside, right? I don't necessarily like this because just as a general rule of thumb, don't stick your passwords inside of a repository. So like, I know that's like, I know, but like you just don't do that. You don't stick it anywhere that's going to get replicated, copied, and pulled down. You just don't do that, right? I run into this all the time. We teach like multi-week classes on cloud and modern software development and all this. and it's shocking what people will stick in a repo. Here's a cool thing. If you stick your AWS like password keys inside of a repo on github.com, Amazon will actually call you in an average of about 10 or 15 minutes, letting you know that they've locked your account on that portion of it so that you actually can't use those keys anymore, which is actually kind of cool. Do you know how many scans they must be running concurrently on github.com to find it when you just stick your random repo out there? I think that's actually pretty awesome on their part, regardless. All right. Questions about Docker Compose before we move on? I realized I should have posted this repo in there so you could go kick the tires on it yourself. Let me put the other one in there. Oh yeah, we went through all that. Did we go look at the other repos? Bear with me just one second. There it is. All right, I'll post this out there as well. These are the ones we look at. I would say Docker Compose is not used a whole lot nowadays, Tom, because of the popularity of Kubernetes. Some people, there's a project out there called Compose. Just type that in chat, which allows you to, I think, use Docker Compose files. I've heard about it. I haven't used it. But for the most part, people just try and solve it in Kubernetes because they want to be able to use production. Like it's like in their local environment, they want to be able to practice using production grade files. So they just write Kubernetes YAML files and just do that, right? Or they use tools that write that. Most modern enterprises don't allow people direct access to a Kubernetes cluster. This is probably worth stating to everybody, is that if you are a developer in like, you know, Honeywell, ThoughtWorks, whatever, this is not giving away any secrets, you don't get access to the Kubernetes cluster. You get access to a location that you can specify where your repository is, but they won't give you access to the cluster. They don't give you any access, no command line, nothing. As a matter of fact, even your YAML, when it's just like put up on a CI/CD process, is thoroughly scrubbed, sanitized, and parameterized before like they'll even ingest your repository. They won't even accept you know, plain clothes YAML in some cases. So I don't know that I've been in an environment yet where they're like, hi, here's a cluster. Amazing developers for project A, go to town. They don't do that. They're like, hi, here's a platform that we've got 50 different groups using, and we have a methodology that you have to follow, but you don't get access to Kubernetes. So just know that most groups don't do that. Now, with a startup, it's a little bit more wild, wild west because I work for startups and for enterprise companies. Startups will be like, hey, here's your cluster, go to town. And the operations folks are like, oh my gosh, what are you doing? Right? So, or they'll say that, you know, 3 months down the road. I have a buddy, by the way, who works for Equifax. I'm sure you're familiar with Equifax's big hack. He just started after they got hacked. He was there like, I don't know, 3 weeks or something, and then they had that huge hack. They had to unroll back all of their direct access to clusters. And of course, people quit because they were like, we no longer have the ability to get direct access to clusters. The developers are coming afterwards, by the way, are so happy because they don't have to manage a Kubernetes cluster. They just write code. They do a certain file, a YAML file usually, that they have to submit, and then that it gets deployed into production, and they can actually see all the metrics and manage the whole thing. But they're so glad not to have a Kubernetes cluster. So most people don't complain about that. So just so you know, that's how most people handle it in the enterprise, at least. Okay, let's see. A service, which we just went through in the file, is what the Docker Compose file refers to when it's talking about, hold on, when it's talking about, dang it, did I just lose my stuff? Hold on. Nope, just do it again. Let's do that. A service, by the way, is what we were talking about before when we were talking about these little definitions. This basically is equivalent. A service is equivalent to a container. Just to make sure that was clear. Specifying service is the same as specifying to a container, just like specifying a pod for the most part in Kubernetes is like specifying a container. Now, I know some people will take issue with that because you can have multiple like containers in a pod. Most people do not run multiple containers in a pod unless they're operational security containers. There's typically only one application container in a pod in Kubernetes. But for Docker Compose, they're referred to as services, and there is typically one and only one. Actually, I don't think they're going to only be one for a service. So there's one container for a service, right? By the way, build usually actually refers to a directory where the Docker file is at. It won't refer to the Docker file itself. So you want to actually specify that. Here you are showing kind of what we did before, where there's like a service name and it's doing build, right? And then service B and it's doing a build, and service C, and there's a link, by the way, to A and B. So A and B have to build first before C can build. That's what that just said right there, by the way. You can't, by the way, link two things together. Oh, A depends on B and B depends on A, because when it parses it, it'll get really confused about, it'll throw an error and say, hey, what do you mean? Which of these do I need to start first, right? Obviously, environment variables we talked about. I would prefer that you do these on the command line if you have to do them. Otherwise, I would prefer that to be hashed or some other variation, or even refer to a secret instead of like call a secrets database instead of running this on the command line. But I will tell you, some of these containers require it. So you're going to have to like do a little jury rigging to get some of these to function. In that case, you need to roll your own container at that point in time. I usually don't like databases that do this. And that's it. That's Docker basics. That was a lot, was it not? All right, I'm not going to quiz you or test you on anything. I'll do that when we get back. Okay. So does anyone have any burning questions about anything I covered or anything that like stood out or whatnot? Okay. All right, so as promised, we're then plus or minus 5 minutes of 11:45. We're going to take an hour and 5-minute lunch. Don't worry, I'll squeeze the rest of the time out of you this afternoon. Okay. So we're going to meet back at 12:55. Why such an odd time? Because you're going to remember an odd time. If I said one, you'd be like, when are we coming back? We're coming back at 12:55. Put a timer up. We'll come back at 12:55. We'll do a little bit of a quiz and a review of the material we just covered. And then we're going to get purely hands-on. So we're going to be in our lab environment. We're going to be in Katakoda. So come back in about 65 minutes at 12:55 and we'll resume then. Okay. All right. I'm going to hang out for just a second in case anybody has questions. Otherwise, go have lunch. Get away from the screen, take a walk. Cool. Docker, we talked about before, containerization in particular is just process virtualization. So we're virtualizing processes. So when you run the Docker command line, as you just saw me do just now, what is it interacting with? Is it interacting directly with containers, or is there something in between the containers and the command line that's being interacted with? And if so, what is that? Right, a Docker daemon of some type, at least, right, is there, right, that is doing a number of different things. When containers run on your system, what do they run as? What user do they run as? Any thoughts on that? What user does the Docker daemon run as? For example, if you're on a Linux or OS X system, what is that Docker daemon process running as? If we're lucky, and the installation method that you used is scoped properly, it's probably running as a Docker user, which probably has some kind of elevated privileges. Most of the time, it's running as root, oddly enough, or administrator on the system. If you're using any of the modern installations, they usually scope that out, but some methods will actually still have that elevated, which means, of course, all your processes are going to be running as root as well, right? Or administrator or elevated. Just something to keep in mind. Okay. What is the Docker command if I want to list all of the images that are cached on my current Docker installation? Right? Just that simple. Docker images, right? Okay. If I want to pull an image but not run it, and I want, what are the commands that I use to do that? If I want to like download it. Yeah, Docker pull. Now, if I'm grabbing Postgres or Ubuntu, and I want to grab a particular version of this particular image, what do I need to put? What punctuation and what do I need to put after it in order to download a specific version? That's right. So a colon, and then a specific version minus, of course, the greater than and less than sign, right? I can specify a particular version. So in this case, 1204, that is so old. But I can pull Ubuntu 1204 down. And I got that version on. So if I do a Docker images now, you can see up here. Well, let's see, where is 1204? There it is, right down at the bottom here. Interesting. All right. All right. If I want to run that image that I just downloaded, what is the command that I type? Does it feel like I'm softballing them up there? Because I am kind of softballing them up there. I am kind of saying it as I do it, right? Is there an alternate way to run that other than just using Docker run? I saw an article the other day. It was like 8 ways to run. Oh, I think it was a pod, actually. It wasn't Docker. It was 8 ways to run a pod. But oddly enough, Docker exec will also allow you to run it. Some of that functionality overlaps. So if you type in Docker exec, it'll also run the pod. Oh, sorry, run the container. Sorry, I keep throwing pods and containers back and forth because that's what Kubernetes calls those sets. Is right. They're not synonymous, but they're close. Okay. If I want to remove a running container, I have to do something else to the container first before I can remove it. What is it? Fulong, I like that you were already there, right? Yeah, you got to stop it first, right? It's going to tell you. It's going to say you got to stop it first. Now, what if I wanted to remove the image? What if it's like, I am deeply offended that I downloaded Ubuntu 1204 because I'm a Fedora guy. What do I do now, right? Right? As long as nothing, by the way, is running Ubuntu 1204, it's now deleted. And so if I do Docker images, I don't have a 1204 anymore. It's gone. Right? Just that simple. All right. What if I wanted to create a volume? You ever go to a job interview and they like give you no references at all, and then they ask you like to pop out commands? We don't operate that in the real world. So I'm not offended, by the way, if you actually look up the command line reference to find out, right? But it's probably something along the lines of Docker volume create, is it not? By the way, it just created a volume, right? Interesting, right? What did it create? Yep, it just created something called local. That's a great name for it, right? With the big hash on it. Sorry, not called local. It has a big hash on it, right? I have a Jenkins home and a Jenkins download because I was using those for testing last week, the week before. What is the flag that I put on my Docker run command if I want to mount a volume? -v, good, right? And then let's say it's a volume. Let's say I wanted to remount the Jenkins home, right? Why would I put it there, by the way? What's the left side, by the way? What's the left side of the colon for that -v command? What does that represent? Yeah, the volume name, which is just right there. I mean, I just pulled it off, right? It's the source, right? The volume or bind mount path. And the right is what's going to be mounted inside the container, right? It's going to be at var lib Jenkins _ home. which sometimes that's Jenkins underscore home, sometimes it's just Jenkins, right? Which is the mount directory where Jenkins sticks all of its configurations and jobs, right? By the way, how many of you have to deal with Jenkins? Nobody? Good for you. I do like Jenkins. It has its place, but it's getting a little long in the tooth, actually. Okay, cool. Okay, we just did the exec earlier on. There's probably more to do there, but don't worry, I'll save the rest for the labs. Okay, what can Docker integrate with, by the way? What can you integrate? What can you run inside a Docker container? What are you limited by? Yep, command line interface. So anything that runs command line interface. Architecture is another limit, right? You need to make sure that either there's an interpreter for the architecture or that you built for the architecture in question. Is size a limitation? Are you really limited by size inside of a container? Like technically? I had a buddy of mine, Chris Kelly. He ran a 1 terabyte container, memory resident container one time, just so he could, just to show that you could actually run a 1 terabyte resident container. I think it took all the memory on the system in question. You might have had a little extra, but like, I don't think you ran a full terabyte. Anyway, regardless, so there's no technical limitation on a container. You can run any size you want to. We did mention, by the way, in the previous section that there's actually an architectural design pattern that goes really nicely with containers that would probably tell you not to run a 1 terabyte container, at least not until it's the year 3000. Is there a way to change the default location that backs a volume on a per volume basis? Greg, that is a great question, actually. I don't know the answer to that, actually, but I'll get you an answer. I will find out. I don't know that I've seen one on a per volume basis, but I will find out. I don't know. The answer is I don't know. Yeah, I'll find out. All right. Now, what is Docker Compose used for versus Docker? Like, what's the difference that makes you want to look at Docker Compose versus Docker? Why would you use one over the other? Okay, so Docker Compose, if you need to run multiple containers all in the same orchestrated space, like if there's one product that's made up by 4 containers, Docker Compose would be a great use case for that, right? Docker's really great for single container runs, although you could just run 4 or 5 Docker commands, but it's probably better to coordinate a set of services, especially if you're going to share them. Okay, now, here's a different question. What is the name of the command to create an image? The Docker command. Okay, what do you do in order to tag that image on the command line? For example, if I was going to do a Docker build, did anybody see that? Maybe you didn't see it. What is the name of the flag, right? It's T, right? You're going to put a tag on it, right? Right? And then I could build and I could base that off of a container ID, right? If I have Jenkins running, I could just, you can take any container you got, right? If you want to like base it off it, you can actually make that into your own tagged version of a container easily. Stopped, started, doesn't matter, right? By the way, does anyone know the command if you want to push that up to a Docker registry? If you've tagged and built your own image and you want to push it to a repository, what's the command for that? How many, by the way, how many of you have done that? Have built your own image and pushed it? Okay, good. Some of you will today, by the way. Some of you will at least build it. You'll understand how, and then push would be the next obvious command. What's the name of the file that we specify whenever we're going to build? What's the name of the file we specify? Good, Docker file. What's the name of the Docker Compose file? Good, docker-compose.yaml. I think it will also accept yeah, thank you, Mike. Mike got it, right? Or YAML. Most of them will, by the way. If they accept a YAML file, they'll accept a YAML versus a YML. Okay. If I want to expose a service, want to expose a container, what do I type? What's in my Docker file? What's the leading command if I want to make a service available, right? It's expose. See how I'm beach balling these up so you can just catch them like balloons and bounce them back at me, right? Making it super easy because I know what happens after lunch. We all go into a little bit of a coma. It's all good. Okay. By the way, by default, if I do not attach anything special to a container and that container crashes, what happens to the data in that container? It's gone. Def null. Good job. Yeah, it's just deleted, right? It's gone. Now, in Kubernetes, I would attach a persistent volume, which would include some kind of storage class with a certain kind of driver attached to it, blah, blah, blah. I just said a bunch of words. May not make sense to you. What would I attach to Docker if I wanted to persist the data? Good, we attach a volume. Okay. All right, questions about anything that we did or did not cover in the prior chapter? Okay. Let's talk about labs. Okay, so first, we're going to do the labs from the official coursework. And then I'm going to throw in some extra labs in there, like a list. I have the list. I'm going to have to find it really quick, but I do have a list of labs that I recommend you going through from Kata Coda. And I'm going to put some links out there. So give me a second for that. But the first thing we're going to do is we're going to do labs 1, 2, and 3. I told you we're going to be hands-on. We're going to be hands-on for the rest of the day. I'm going to walk through these because I'm going to let you go solo on them. And then I'm probably going to take some periodic time to review certain labs just to make sure you understand exactly what we're doing. So let me blow this up a little bit so this makes a little bit more sense. Okay. So the first is the setup. Just to say this, make sure that you CD to the works directory. Why? I don't know that there's anything in there, but just in case you need it. Lab files might be in there. So lab files, by the way, is the directory where most of the YAML files are, but most of this doesn't require YAML files except for the Docker Compose stuff. So, and we just make sure that you're in the right directory. This, by the way, a little tilde means home directory if you're not familiar with command line. All right. So you're going to get familiar with the Docker command. You're going to run it yourself, right? We're going to do a PS with a -- help. You'll list your images. You're going to do a bunch of the stuff that you saw me doing earlier. You're probably looking at this, by the way, if you're a veteran, you're like, I don't know, Michael, I've done a lot of this already, right? Just humor me. PS-A, right? Removing the container in question, right? Again, just basic working with containers. You're not going to have an issue, by the way, running this command. It's only Michael Forrester's box that's having an issue today with this, right? Notice it specifies a host name. And this is the image pulling latest, right? So you are going to run this in interactive mode with a TTY, which is just a terminal. Once you get in, by the way, make sure you type exit to get out, unless you want to mess around. And so you're just going to be messing around with a bunch of containers, images, see them pull down, run them, just to get a feel for the whole thing. That's just lab 1. Lab 2, you're actually going to basically run an image, and then you're going to take an existing container ID. What's the container ID? Well, container ID is this little crazy alphanumeric that you're going to run when you run a PS command. You can also, by the way, use this randomly generated name, which in this case is amazing panini, which, by the way, paninis are really tasty, especially ones with basil on them. But like you could do Docker commit amazing panini, or you could actually put that long alphanumeric in there. I would experiment with how many digits you need to put in, because you don't have to type the whole alphanumeric. Sometimes you can actually type in anyway from 6 to 8 digits, and as long as it's unique, it'll run it. I typically just use the host name, but you don't have to type in the whole alphanumeric. It's weird though, the rules that it follows for that. So, you know, if you want to shorthand it, you can. Now, notice in this case, right, it's running a Docker commit. Again, just take a look at it. And then here's Docker images again, showing you committing, having like put that into your repository. And then here's a Docker run. You're actually running the container you just created. You're actually invoking bin bash out of it, which, by the way, just came off of the Ubuntu image, so it should have bin bash in there, no problem. It probably is a good idea to delete images that you created. Be careful though. Don't try not to delete any of the like Kubernetes ones. It's not like we can't reinstall Minikube. It's not like it's that big of a deal, but you might run into unexpected errors, right? Here we are, the RM command in action. So this removes the container that was running and potentially is stopped, and then has a difference from the RMI command, which means remove image, not remove the container. Different spaces. Remember, image is your bootable set of images. Containers is the stuff that you've run or are running, right? And then you just review it. And then last but not least is that you're going to create a basic Docker file. You don't have to, by the way, put the comments in there unless you want to. You can play around. Maybe you want to grab a different tag of OpenJDK, right? But you're going to copy the simple greeting.snapshot from the, I think it's the workspace directory is where it's at. Oh, actually, no, it's in lab files, right? And then you're just going to ls, right? That's it. So you're going to copy it from lab files into your working directory so that when you build it, the file is actually there. And you're going to tag it dev openjdk version 1.0. And don't forget this little period. That is not an artifact. That is a period on step 7 inside lab 3. That period on step 7 is real. It's not a mistake. Make sure that's clear. That period, by the way, means this directory, the one you're in right now, the one I'm in currently. That's true, by the way, if you cd to any directory, it means this directory, basically. If you cd ... by the way, it means the directory above, the parent directory. So then you're going to verify the image, right? You're going to run it. Just make sure it's cool. cd to root. Verify that the simple greeting.jar is there. It's very simple, right? It's very, very simple. For those of you who are veterans, you'll probably zip through this, but don't worry. I have a list of more and more advanced Docker commands to run on Kata Coda that I'm going to post out here in a second. That's what we're going to do. Straight up and simple. Anyone have any questions? Okay. This isn't necessarily the rest of our day, but it'll probably be the bulk of the rest of our day. We might cover some material on Kubernetes just to kind of get that started, but we're going to take at least the next hour to work on labs, maybe a little less. It just depends. Okay. So I'm going to check back in about 30 minutes. I'm not going anywhere. I'll be right here. Mike will be open. You can talk to me, ask me questions, right? Let's see, Mike, are the lab files already in the UMBC lab somewhere? If not, how do we copy into there? The lab files should already be there. When I checked in mine, they were there already. I'm assuming, by the way, did everybody get an email from me talking about directions to register and kind of what the steps to follow to get UMBC working? Did everybody get an email from me yesterday? Okay, good. See some head nods. So if I got 2 of you, that means I got all of you, right? Yeah. The environment. I've got mine bookmarked. I'm going to actually post the link in case somehow if it was even remotely misplaced. Here, I put me right back into my environment. Notice that I'm in works, has my working directory. I believe if I go back, there's a lab files in your home directory, assuming that I can lab files to it. And inside that, it also contains a bunch of files as well for the lab. But again, just follow the directions and you'll be fine. Okay. All right. Let's go forth. Let's do labs 1, 2, and 3 from the official work. I'm going to post a short set of labs from Kata Coda for a list for more advanced work here in a second. If you have any questions or concerns, or you're looking at something, you're like, Michael, I don't even know what this does. I'm confused. Raise your hand. Let's talk about it. All right. Check in about 30 minutes, maybe less. All right, so Kubernetes was originally a project that came out of Google, right? I think it was referred to as 7 of 9, sometimes referred to as the Borg project, right? If you're familiar with Star Trek Voyager, you know where that came from. It's Greek for helmsman or pilot. It's where the word Kubernetes or governor, gubernatorial comes from. So Brendan Burns, Joe Betta, and Craig McLuckie were considered kind of the original founders for the idea. And it's actually, its variations are still in use today. So they're still running strong over in Google with whatever variant they have. Kate's is the one that they published out to the public, right? This is now owned by the CNCF, just has a extension. Probably worth stating that the CNCF, if you haven't been to the CNCF before, the Cloud Native Computing Foundation is probably like, it's a consortium of like different major tech players, but also some minor ones that are basically creating all of these projects that are being used to revolutionize how we use technology, how we do infrastructure, how we basically deploy inside of our technology landscape. So there is a landscape picture that's actually pretty useful. If you've seen this, the interactive landscape map. This is quite an eye chart, just to say this. So I'm going to put this actually so you can see it yourself in your own local setup. The only thing that I would like to make sure is clear is that if you go on the left-hand side and choose CNCF relation and just choose projects, what you'll see here is you'll see some of the biggest names in computing, such as Kubernetes, which is right here in the middle, etcd, which is the core data store on the back end of Kubernetes. Just to mention this, by the way, if you ever get access to etcd inside of a cluster, you pretty much own the cluster. So just something to know about, because there's a lot of stuff in there. Helm, which is is a graduated project, which is considered to be a core project for deploying applications onto Kubernetes. Think of it as a software repository, kind of like Brew, Homebrew, or like Chocolatey is for Windows and Mac. Envoy, which is the underpinnings of Istio and a couple other, Linkerd, for example, which is used for like sidecar proxying for creating service meshes. So there's a bunch of projects here that are pretty much the core, including the Open Policy Agent, which is really important for security. Gatekeeper, OPA Gatekeeper is starting to replace pod security policies, or at least enhance them by doing funky things with the emission controller. And then Containered, or Containerd, right, as we jokingly refer to, which is kind of like one of the core container runtimes for Kubernetes. There's other projects out here like FluentD, which most people are familiar with, Jaeger, which is used for tracing, and then Prometheus, which is used for metrics inside of Kubernetes. So this has become very, very popular, right, inside of anything the CNCF is working on. Basically is becoming the next new thing. If we then expand this list of projects, by the way, to incubating and sandbox projects, you get exposed to a wealth of new things that are on the horizon. Some of these will take off, some of these won't. Like Linkerd, by the way, is an incubating project, Linkerd. Linkerd is probably not as popular as Istio, right? So who knows what the fate of Linkerd is long term, but it's there just in case. All right, just wanted you to be aware of that, because that pretty much will tell you what's emerging on the landscape and what you need to pay attention to. Security and compliance, by the way, has a bunch of pieces, including Falco. Rotary is used. Oh, I forgot what Rotary is used for. No, I'm sorry. Notary is used for signing, I believe. Tough I haven't used. OPA I have used, right? And there's a couple of other tiny little things in process. OPA has probably been around for a couple of years. Probably the de facto way that policies are being enforced, defined, and executed inside of Kubernetes. Yeah. And then there's KubeEdge, which I talked about before. So good place to keep an eye on if you're wondering what's going to be emerging into the landscape. But back to Kubernetes, just plain Kubernetes. So we talked before about how K8s or Kubernetes is an open source system for automating deployment, for scaling, for management of containerized applications. And it groups application containers, right, into its own deployment unit or segment called a pod. Typically, you do not deploy more than one application container inside a pod. For example, people are tempted to stick like web and database containers into a single pod. No, that's not a good practice, because then you have to scale them together, right? Which means you're going to be scaling a database at the same time that you're scaling a web server, which you don't do that. So we want to keep them separate. So you want to follow separation there, but you can actually create relationships between pods, right, between containers, in order to make sure that they like stay in tight lockstep and can scale in somewhat of a relationship to each other. So it's designed to easily scale applications, but there's a couple of different deployment types, which we'll talk about, right? Kubernetes will basically run anywhere there's an operating system that will support Kubernetes, right? For the most part, that is now Windows 2016 and above for running Windows containers, and basically any Linux kernel that has the necessary extensions inside of it. So this will basically run on-premise, in your cloud, on the edge, right? And most of the public cloud providers in particular have a managed service for it. So it says it can be deployed on a bare metal cluster, like physical machines, which is true. You do need an operating system at present, although there are projects in the works to change that reality or fate. So its primary role is all the orchestration that we talked about, right? And of course, they have to add in here, it's great for microservices, because it is, actually. So here's the concepts. You may be aware of this already, but you have the concept of master, basically nodes, master nodes, and then you have application nodes, but we strip off the words there. And so you've got primaries or masters as the primary like setup, and then you've got nodes, which are basically the workhorses that host all of the working pods. So masters host all of the necessary applications for like API server, cloud controller, admissions controller, all the other pieces. And the nodes themselves, which used to be called minions, no longer referred to that, they contain kube proxy, kubelet, and other software necessary to stay integrated with the cluster, but also to do some network routing as well. Every pod contains at least one application container, but you can actually have multiple containers in a pod. They might be operational, they could be sidecar, they could be security. It's general best practice that in a pod you have one application container. So let's talk about some of the other concepts other than just the fact that we have pods that have containers on them. They're running on nodes, application nodes, and they're being scheduled, controlled, and managed and mastered by the masters, right? So let's talk about the cluster itself in a namespace. Clustering, not a unique concept, right? If you're running a database cluster, that cluster is focused on hosting data, right? If you're running an application cluster, that cluster is focused on running applications. So think of a cluster as just a collection of resources, mainly hosts, that are focused on one outcome. Usually there is some sharing of either networking or a namespace or something going on within the cluster to maintain state or consistency. Now, with Kubernetes, etcd is a NoSQL distributed data store that's used to basically maintain state in the cluster. And those are usually hosted on the masters, but they can be externalized. So you can actually run etcd separate from any other box or any other structure. So the entire system may consist of multiple clusters. I don't know about that. There's some work to create meta clusters of Kubernetes clusters. You can actually slice clusters up into different boxes that have different like responsibilities or focuses. I don't know that you would create clusters inside of clusters. Not yet. There are tons of things to work on that. Rancher, for example, will allow you to create clusters that get federated together. But Rancher is a third-party piece of software. It's not part of the kind of native Kubernetes landscape. They're a great company, by the way, and their open source product is exactly like their enterprise product. So if you want to kick the tires on them, they're a great tool to have. But let's talk about namespaces. So we got a cluster, which is a collection of machines with a common purpose. So by the way, the masters and the application nodes are all part of the cluster. So they're all part of this like, big cluster set. So in like this diagram, for example, all of this is part of the Kubernetes cluster. The namespace is if you take this and you virtually slice it. It's an abstraction, right? It's where you say, for example, I want to slice up this cluster. Let's take a look at that. You ever feel like you just have too many windows open? Just kidding. So in this particular Minikube setup, which has been modified and messed with quite a bit, notice that there's a default namespace, which is by default where if I run a pod inside the system, it's going to run. And there's also an Ubuntu and a Jenkins one, which I added actually because I was doing stuff. There were quite a number of others here, and I've kind of pruned this whole thing down. But notice there's a kube node, kube public, kube system, Kubernetes dashboard, right? So that way, if I wanted to like run a dashboard, which by the way, this is very specific to Minikube, you could actually see like this dashboard application running in that space. The dashboard, by the way, is really cool if you need to visualize things. So, but these are all slices of the cluster. So think of these as like, in a sense, almost like security cordons. There's like little, like, hey, you're in this hallway, you're in this hallway, you're in this hallway. And you can actually tighten them up so that people obviously can't see other people's spaces unless they have certain, basically permissions inside the cluster, right? Otherwise, if you're running an application in Jenkins, it's usually can't pop across the namespace to see somebody else. So think of these as like security cordons that you can set inside your cluster. And you can actually enforce them more and more heavily if you set a particular policy to be as stringent as it needs to be. So namespaces are just like, in a sense, organizational slices that have security context on them that you can set inside your cluster. That's all it is. So you can actually have multiple namespaces. I can't remember the last limit. I want to say it's like high. I could probably look it up. It's at least a couple hundred. I know because I've had a couple hundred namespaces on a cluster before. So these basically separate these out by namespaces, and they can connect through public interfaces. So you can have one service talking to another, no problem, right? Pods, by the way, can live in particular namespaces. Obviously, nodes, which are virtual or physical machines, they're part of the cluster. So they're part of the whole thing. Can you make it so that a namespace doesn't include a certain host? No, not. I mean, you probably could if you wanted to go in and change the code, but for the most part, every node is part of every namespace. You can, by the way, schedule pods from different namespaces to run on the same nodes. But honestly, that's usually not a consideration for the scheduler. The Kubernetes scheduler, unless you tell it otherwise, is not going to take into account like, oh, this namespace cannot run with this namespace, right? It doesn't. You can set that up if you want to, but it doesn't normally take that into account. It's not part of its predicates calculation. Nodes, on the other hand, formerly referred to as minions, are really just hosts. That's what they're for, or application nodes, right? And they are used to run pods, which we've already talked about. And this is really the pod, to me, is like almost the basic unit of deployment, right? So when you create a deployment, create stateful sets, create daemons, jobs, right, which are also known as batch jobs, you are typically running a pod. So the master is the primary controller of Kubernetes. You can have more than one, of which one is usually elected as like the leader, if you will, right? It includes things such as an API server, a scheduler, a controller manager, etc. I wonder if I have a good picture. I don't. Oh, that's interesting. I wonder when that got taken out. Let's try something else here. Let's take a look here. Let's blow that one up. Platform 9, they're a good company to deal with. All right, so here, by the way, you have what's, by the way, the master is sometimes referred to as the control plane. And so you have etcd with a controller manager with a scheduler talking to the API server, and they're manipulating things back and forth, right? And then you've got kubectl, which is hitting port 6443 on your cluster and is interacting with the API server as well. Now, what's happening is that API server and these controllers are all interacting with the kubelet which is running on the nodes. By default, that's all supposed to be secure communication. They've kind of been evolving that over the years. There are ways to make it more secure. But the kubelet, yeah, anyway, I'm going to get into that later when we talk more about security. But just know that all of this expects predominantly a private network, and most of it's encrypted depending on how you set up the certificate authorities and TLS between all the systems. And what's happening is that everything on the master is doing most of the work to talk to the kubelets, who are either interacting with kube proxy or interacting with and scheduling the pods themselves. This is the interesting part, because just to say this is that these nodes right here are actually having to download the pods, I'm sorry, the containers, right, inside these pods from a different location. So this is where the repository becomes really important, because these guys are going to have to download their stuff from a repository location in order for them to be able to stay flexible with everything. So you do have to have a repository really for a cluster to function. Without one, it's going to be really, really tough. Let's see, where'd that little gem go? Oh, there we go. All right. So switch over for me. etcd is the database. The controller manager, right, controls a bunch of things. And by the way, there is a cloud controller that will start up, because the cluster will be made aware about whether or not it's on AWS, because there's a cloud controller for AWS, there's a cloud controller for Azure, there's a cloud controller for GKE, right? There are a remarkable number of cloud controllers that are spun up depending on where the Kubernetes clusters is made aware of where it's running, right? So, and of course the scheduler just shows scheduling. So there can be more components here, like a storage manager. And most of this all just runs through the Kube API server. But these are the core components that make up the master, the primary inside the Kubernetes cluster. So with all of those responsibilities, it's responsible for cluster level scheduling of pods, the handling of all events, maintaining replicas like healing, right? Maintaining connectivity with storage, making sure that services and everything are all in a consistent state. And by the way, if it's managing external objects, it's responsible for enforcing the consistency and availability of those external objects as well, at least as far as it can control the API of that object. So, you know, if AWS has an outage and you lose your load balancers, can't do anything about that, right? So one thing to note very clearly is that you typically want it, you know, an odd number of masters inside your setup, but you at least want more than one if you're going to do a production setup. I remember the last like size for a vanilla cluster. I want to say that, oh God, what was it? It was something like super high, at least like 1,000 nodes or something that you can get inside of a Kubernetes cluster. 1,000 nodes. So this is 1,000 host machines of size, right? So these boxes can be pretty massive. From a networking perspective and a management perspective, I think as of 1.2.0, you're limited to about 100 pods per cluster. Sorry, per node, not 100 pods per cluster. That would be horrible. 100 pods per node, right? If you're using like a custom distribution like Rocket, which is Rancher's version of Kubernetes, I think that climbs up to 200 pods per node. That's usually the default. You can tweak that. Just know that you could run into performance problems if you put more than 100 pods on a single node. So, all right. Questions thus far about nodes or masters or any of the clustering components? Okay. All right, so let's talk about pods. All right, pod's the basic unit of work. So if a container is the basic unit of work, Docker, services are basically containers inside of Docker Compose. Pods are the basic unit of deployment and work inside of Kubernetes, obviously with containers contained inside of them. So it's a way of grouping containers, especially containers that have like application concern and then one or more operational and or security concerns or other enhancements, right? So pods do provide a solution for managing containers that depend on each other and cooperate on the same host, right? But like mainly this is for a stateless setup. Stateful is certainly not a horrible issue, certainly not in 2021, but it was originally designed for stateless applications where you externalize it out, and then they started adding state capabilities into the system. So nowadays running a stateful application inside of Kubernetes is way less harder than it was. And especially with the inclusion of operators, which are ways to create custom resource definitions that have operational intelligence inside of a Kubernetes cluster. Operators really allow you to basically take like DevOps best practices and wrap them into a Kubernetes response. So it knows how to manage stateful applications a little bit better, right? Each pod, of course, just like a container, gets a unique ID. Pods, whatever's inside the pod, gets scheduled together and run on the same machine. They share networking, they share like a memory space, they share networking space, they share a bunch of things, including storage, right? Or typically access to storage, although you can segment it. All the containers in a pod have the same IP address and port space. So you got to be careful of collisions, obviously. And the containers within a pod can communicate each other just using a local loopback or using inter-process communication because they are sharing similar memory spaces as well. So think of the pod as another like security cordon around the container set, if you will. Oh, then it says there, containers within a pod have access to shared local storage on the node hosting the pod. But again, you generally want to use the storage class that's abstracted away from the host. If you have 50 hosts in a cluster, you don't want to use local storage unless it's just transient storage, right? You're going to want to abstract that storage either out to another storage system, to NFS, iSCSI, some variation thereof. Do not use local storage for the most part for in a Kubernetes cluster. With Minikube, it's fine. Some of these statements. First of all, inside of a container, you typically don't run more than one process. Why? Because if the other processes die, the container won't know, and you'll just be in a failed, weird state, zombie state. Typically, don't get me wrong, you can run subs and threads out, but typically it's one application per container, one application container per pod. So it says like the benefits of grouping related containers within a pod is having one with multiple applications. There's a bunch of implications here about like that you might run actually more than one application container within a pod. And that's typically not best practice. I'm sure there's use cases where you'd want to do that, but typically you don't, right? It does actually make things in a sense easier, but really what you want is one application pod and a bunch of operational security pods if possible. All right. So the reason that billing is hard inside of cloud is because people don't tag their stuff. Maybe like, Michael, why are you talking about this? Remember I said there were two things hard. In cloud, it was billing and security, and in Kubernetes, it's security and networking. So what's interesting is that by default, Kubernetes uses tags called labels, and it also uses annotations, which is just arbitrary metadata, right? To basic, which I say arbitrary, it's actually, it can be very useful, honestly. But labels are basically key value pairs like image equals nginx or name equals, right, my nginx or version, whatever, right? And basically every single object in Kubernetes, which by the way is driven by APIs, but every single object in Kubernetes ends up with a label. And so when you manage it, you just run a label selector in order to select the items that you want to run in which way, right? So each pod can have multiple labels. And each label can be assigned to different pods. So it's not like you're restricted, right? You can assign that label many times over to many different classes of pods as you see fit. But I will tell you, each label on a pod must have a unique key, right? So you can't, right? You can't have like a key and value, right? You can change that, but the key's got to be at least unique. The value can be different. So there are actually three parts to a label, right? there's the prefix, which has some limitations, right? It's optional, right? You don't have to put it on there. So usually separated by the name by a /. It must be a valid DNS subdomain. So you'll see like com, right? Prefix must be 253 characters long at most. The name is mandatory and has to be 63 characters long, and then values follow the same restrictions. So both keys and values have the same restrictions on that they have to be, names and values have to be 63 characters long. Is there any separation at all between multiple containers sharing a pod? Not really. They share the same memory space. They're in the same like permission set. They're sharing the same storage access. They're sharing the same network. So you can create some, but for the most part, whatever's in that pod they have access to each other. So Mike, just to say this is that's why granularity wise, you should be separating everything out, right? If there's operational and security containers in the pod with the application container, that's totally fine. Reading logs, maybe intercepting network traffic because it's actually doing some kind of filtering or rate limiting or metering or whatnot, or caching. So you just have to be careful. The only thing you stick inside a pod with the application container is anything that you expect to have a certain level of access to the application container. If it's there, they're sharing the same space. So there's definitely container level separation, and you can create more separation, but you have to, by default, they have really relatively unrestricted access to each other.
Okay, thanks.
Yeah. Let's see. Let's put labels in action here. First of all, is my kubectl working? Oh, probably if I spell it correctly. All right. Once again, just leaving it off, huh? All right, so let's see. Let's do. Oh, probably help if I actually describe the pod in question. All right. So this is me describing a pod. In this case, it's the Jenkins pod. And see, here's the labels. I didn't create any of these labels, by the way. Oh, don't worry. I gave it names. I gave it values, but it took the values and actually put these labels in. I could have added labels to the system if I wanted to, right? But notice that if it's got a prefix with the / before of it, it looks actually like a domain name. That's a requirement, by the way, if you create a prefix in front of a name value pair, is that this has to be a domain name. And then here's the actual name component. And then here we go. There's a Jenkins controller, right? Here's the name. Here's another component, CI/CD. Notice was this done by Helm? I guess it was, right? And then here's the name, Jenkins. So notice that these are all the labels. And then here's an annotation. Now it's funny how annotations are listed as kind of like metadata that isn't necessarily required, because annotations are optional. I actually find that annotation to be extremely useful. And I suspect it's getting parsed actually. So the statement you're about to see where it says annotations are not necessarily used by the system, that's not true actually. So notice the status is running. And then here's the IP address. Notice that's a 172 address from RFC 1918, right? So this is a private address because it's running on a private network. By the way, if there were multiple nodes in my cluster, because I'm running on Minikube right now, right? That 172 address would be shared in an overlay network between the Kubernetes systems, right? So, because that's how it maintains continuity and consistency and connectivity between the pods internally. Notice all the other information that I have, such as the image ID, which we know what this is because we just finished the whole Docker set, right? And then here's the actual specific container ID with the identifier in question, right? But the main thing I wanted to show you was just this particular piece. which is the full like prerequisite domain name for the prefix, plus the name and then a value. So this guy right here is limited to 253 characters. I remember these are capped at 63. Okay. Unlike labels, it says annotations can be used to associate arbitrary metadata. Annotations don't have strict restrictions. Kubernetes stores annotations and makes their metadata available, which is good. I actually think it's good. And it's parsed and used actually. So label selectors. So for example, if I came in here and selected a label where name equals Jenkins, right? I mean, isn't that in a sense what I'm doing with kubectl get, right? So label selectors, by the way, can be used to equate names with specific values, right? Like obviously this is where role equals DB server application, but does not equal sales, right? So basically you can use a set base selector if you want to include n. There's actually a bunch of operators that can be used with your label selectors. So highly recommend that as you get more advanced with this, that you look at the API listing for label selectors to get but kubectl, the command line listing as well. But there's a bunch of actually operators that can be used in this to kind of advance that forward. All right. So that was to talk a little bit about pods, about the labeling and the labeling syntax of pods, and then annotations themselves, which just contain arbitrary metadata, some of which is parsed and used, and that you can actually select something based on labels. You can, by the way, you can label pretty much every object. There are a couple things you can't label, like I want to say like namespaces you can't label. I don't think I've ever pulled that off. There's a couple objects. The cluster itself can't be labeled, but you can label nodes actually. So if you're like, hey, these are the machine learning nodes, or these are the stateful nodes, and these are the stated nodes, and then you can actually put in your deployment file and say, look, I don't want to do any deployment of my machine learning components onto these machine learning nodes. I want them, I only want them to go on the machine learning nodes. I don't want you to go on the stateless or the stateful nodes, right? One thing I usually prefer cluster as a service is that if I can't get away with that, I will actually segment up systems based on, hey, this is where the databases are going to reside. This is where your stateless applications run. Why? Because there's different concerns, again, with state than there is stateless, and particularly with a new team, I will highly recommend that they segment that out just to make sure that they can configure those systems with a little bit more focus. Also, if they're dealing with those boxes and they're only hosting stateful applications, they know they need to be a little bit more careful about what they're doing with those nodes in particular. Let's see. Oh no, let's not do that. All right, let's talk about replicate. I'll come back to that. Let's come back to replication controllers, replication sets. So replication controllers is the old term for basically what replica set refers to now, right? It's an old entity or object that actually is still around but being retired, right? They both manage a group of pods identified by a label selector, for example, web server. And the goal here is what you're trying to do is you're trying to, or Nginx, right? You're trying to maintain a certain number of like say Nginx web servers. So let me put this into a visualization for you. All right. So this is my Minikube cluster. There's a bunch of workloads on the left. If we go take a look across all namespaces, there's a lot, right? Here's the Jenkins one. Here's an Nginx one. Let's take a look at the Nginx one for just a second. These are pods, right? So a couple of things here. Let's see, this was initialized about 7 days ago. Obviously, I started it up here recently. Notice that the replica set says that I've only got one pod here, right? Now, this was probably set up by deployment, right? Could have been this one, could have been that one, right? Most likely this one, because this is the Nginx one. And what I can do here is that if I want to run more of these, what I would do is I would come here and edit this file. I can do this also on the command line. And I can come here and change the number of replicas down to a different number. So let's say 3, for example. Notice that it says this is the equivalent of running this particular file, which is me changing the YAML file. Click on update. What will end up happening is that now it's going to start adding, right, more instances of Nginx to the system. And then quickly, by the way, it transitioned from 1 out of 1 to 3, right? This is all done because I just modified the replica set by modifying the deployment. The deployment basically stated, this is what I want you to do. It's a declaration of how you want things to run inside of Kubernetes. That's what the deployment is for. And then what happens is that all of the other services respond to the declarations inside the deployment, and they do their things. No, if I come over here to replica sets, and I actually change this thing directly, interestingly enough, because now I'm in a replica set. See this in the upper left-hand side? I'm in the replica set. I'm not in the deployment. I'm in the replica set. If I change this to a number, I guess I could do it. I don't think it'll wreck anything. But if I change that to 4 or 5, what it will do is it will actually try to spin up 5 Nginx pods, 5 Nginx containers, right? And then pods. And then what's going to happen is it's going to kill them. Why? Because the deployment says I'm allowed 3, and I just tried to start up 5. So it's going to kill 2 of them, right? And make sure I end up with 3. Because what's king here is what the deployment says. My point in sharing that with you is that right now this says 3, right? Is that replication controllers, and replica sets are their job is to basically scale the deployment up pod-wise to whatever number is defined in the deployment. That's its job. That's what replica sets are there for. So they basically ensure that the exact number that you've specified in your deployment is running across the entire Kubernetes cluster. So if it drops one, it's going to add one. If an extra one is somehow mysteriously added, it's going to delete one, right? So let's see that in action. So let me go back to my replication set. I'm going to go over to Nginx. Notice I've got 3 here. Let's say I come in here and I force this and say, you know what, let me go ahead and make this. Here we go. Let me go ahead and make this to let's say 5. So it just basically updated the replication controller, but it's still running 3. What happened? What did it do? Doesn't make any sense. Why did it do that? Right? Except it did exactly what I just told you it was going to do, right? So let's go to the deployment. Events. It was like, 2 minutes ago, it's like scaled it to 3. What happened to the rest of my stuff? Right? What ended up happening is that it actually deleted the 2 extra pods that I was trying to create, because even though I told the replication set to go to 5, the deployment says 3, so it just killed them and said, nope, I'm not starting those back up. You can forget it, right? So replication sets are the primary like controllers, if you will, of the number of replicas or copies of an application that you have in your environment. Replication controllers basically are on their way out. So you're going to start to see this like particular section retire. Notice there's no replication controllers here. Most people are not. This is kind of a legacy component, right? Okay. The other thing to note is that much like a service functions inside of Docker. Oh, sorry, I missed questions there. What are other examples of Kubernetes objects? So to give you a visual, pretty much all of these are objects. Cron jobs, daemon sets, deployments, jobs, pods. These are all objects. They're usually either objects of deployment or they're objects affiliated with deployment, right? So all objects inside Kubernetes are APIs. And so this can include anything from services to ingress controllers, to config maps, to persistent volumes and persistent volume claims, to like storage classes, for example, secrets. These are all objects. Everything pretty much is an object that's stored inside etcd and is accessible through the API. Service accounts, as an example, roles and role bindings, cluster roles and cluster role bindings, namespaces, right? We saw namespaces on the command line earlier, right? Here's Ubuntu. Pretty much all those. Is there a dump the configuration of everything command or a way to iteratively dump all the things? There is. I don't know it off the top of my head, but I'll make sure that I get you a copy of it. Because basically what you're asking for, Mike, just to be clear, is you're asking for a dump of the etcd database. So there is a way to dump that configuration.
Is the etcd just the declarative stuff, or is that also the state?
It's everything.
Because I was thinking sort of not the running state, but the state that it wants to be. So like all the configuration you would put in before you ever started it the first time in a perfect world, if you knew everything up front. So maybe not the entire etcd, but like all the YAML for all the objects.
That's a good question, actually. I'll find out. I don't know that I've actually done that before. Usually I just end up backing up etcd. But I mean, it's valid, right? What if you wanted to reapply all of the objects inside of a cluster to another
Right,
cluster?
yeah, exactly.
Yeah. Assuming that you had all the repositories and versions and all that, right?
Yeah.
And the storage setup was the same. Yeah.
Yep.
I will find out. Pardon me. Okay. So those are all examples of objects, pretty much everything that makes up. You can also create your own custom objects if you want, using the custom resource definition. So you can extend to both the API and the object definition for Kubernetes. Okay. So you started a pod. It's got a container in it. You want to expose it out. Well, by default, right? If we take a look, good note of that. What happens is that the pods have their own private IP networking space, right? So they can be seen by the local hosts on that 172 address because it is somewhat bound to the local system, right? But what if you need to expose this out, right? What if you need to hook it into a load balancer or expose it to something outside of the cluster, right? Because remember, this is an overlay. The 172 network is an overlay network, right? So the cluster can see it internally, not externally, right? So here what you're doing is with a service, you're actually exposing it out. Now the service could hook into 100 Nginx's on the back end. It could hook up to 1, it could hook up to 3, it could hook up to 5, up to 100 on the back end. Like that's the point of a service. Because the other thing that happens is as pods die and move around, their IP address changes. So then how do you maintain consistency of connectivity when you've got this living, breathing ecosystem of containers running in pods that are all dying, being moved around, hosts are failing, things are moving around, which by the way, does create somewhat of a security challenge because I frequently am asked when dealing with security environments, they're like, hey, can you give me a list of all active IP addresses bound to all of the pods right now? It's like, I sure can. And I don't know what you're going to do with that. It's going to be a lie after I print it to you. It's going to change, right? But I understand where they're coming from because they're like, we got to capture this. I got to figure out how to map this and what does this look like? But Kubernetes ecosystems by default are super dynamic. So when we inspected, like Jenkins earlier, it has a 172 address. If that pod dies and gets restarted, it's going to end up with a completely different 172 address in the environment. So services are a way to answer that, right? By basically saying, hey, what if I had a single, basically either IP address or DNS name that I could go to, and Kubernetes would always route me to the appropriate backend pod, assuming that there was one active to service the request, right? So like in this case, you see that there's a couple of different services here, ignoring the Kubernetes service for a second. But CI/CD Jenkins and the Jenkins agent, they're running on 8080 and 5000 because those are the ports that you use to talk to Jenkins, right? If you're doing localhost 8080, that gets you to your local system, right? And you can, for these particular ones, this is actually using a cluster-wide IP. There's 3 modes, by the way. There's cluster IP, there's node port, and then there's load balancer. Now, that load balancer, by the way, could be an internal load balancer on the Kubernetes cluster, or it could be a cloud-based load balancer. It could be, an application load balancer, or a network load balancer on AWS. It could be an Azure load balancer. It doesn't matter, right? But notice there's no load balancing type here, right? There's only cluster IP and node port. Node port, by the way, binds to a specific host, so you can run into collisions. Cluster IP, in a sense, is kind of like a node port, but across like the entire cluster set, so like things can find each other. You can run into collisions there as well. Notice that the cluster IP is a 10 address. Again, something for the cluster that isn't necessarily pod specific. But services, that's what they do, is the service gives you an endpoint that's either DNS based and or IP based that allows you to find all your services on the back end. So you've got the pod networking, you've got the clusters networking, and if you're externalizing it out of the cluster into, say, like a load balancer, you've also got the load balancers network outside of the cluster set itself. Remember, I said that networking was one of the 2 hard things inside of Kubernetes. There's whole books written on this, by the way. Now, when we are using cluster IP and you hit a box that doesn't have a running pod on it for the service you're trying to hit, Kubernetes will route you to a box that has, it will route it. It'll load balance. It'll actually push you towards a box that has the right pod on it that you need. Let's say you got 50 hosts. You got 3 of them running a web server. You come in and you hit the IP in the port. The cluster knows, it's like, oh, hey, only these 3 boxes are running it. Go talk to these 3 boxes. It'll redirect you, right, over to the right boxes. Is that super scalable? No, it is not. It will not perform well under heavy load. Please use a load balancer of some type if you plan on having, I would say like a couple of thousand connections per second on a system. You probably need to run your own control, like your load balancer. If you want to do that, don't rely on the cluster to route that for you, right? Besides, you want to save those resources for something else. So services are how you expose things outside to services to outside the cluster. Okay, storage volumes, right? Interesting the way storage volumes work, right? Storage volumes have a couple of different components. I probably should just leave that up, actually. That's weird. You didn't fail, but you're not running either. Oh, bear with me just one second. I think my system's thinking about whether it's going to crash or not. That's weird. Yeah, thanks. You didn't start up. That's weird. All right. Huh. That's weird. Hold on a second. Find out later as to why that didn't work. Or maybe it did, and I just didn't see it running in the background. Interesting. So storage has a couple of different components to it. So storage is interesting because the first thing you really have to do is you have to define a storage class, right? So if you come in here and like you want to do a YAML file, but like if you're, this is like the standard storage class in Minikube, which is really just a like local storage, right? That's all it is. It's basically an 8 GB volume that's basically defined as a persistent volume inside the system. That's a storage class. And this is just a local host path. That's all it is, right? Now, what kind of storage it is dependent on which driver you choose when you load the storage up. So you can load NFS, you could load EFS, you could load a variety of storage drivers into the system that will give you access. You could, like NetApp has native storage, EMC has native storage drivers that you can actually put in Kubernetes that will allow you to hook into the storage, and it teaches Kubernetes how to manage those like particular storage paths, right? Now, what then has to happen is that you then need to define a persistent volume claim, like in this particular example, right? Here, let's see. Oh, wait, that's the storage class that was created for this. Sorry. Standard storage class running 8 GB. Okay. And so what's happened here is that it's actually claiming an 8 GB capacity, right, off of the standard setup in the default namespace. This read write, there's different access modes, by the way, for storage, but what you need is you need to define a storage class. This allows you to pull from the storage, and then you create a persistent volume claim that basically then you use inside your deployment that says, I want to call and grab this much storage. It looks remarkably like a mounted volume. So if we actually go and look at the deployment, right? Oh, hello, you're not there. Let's go take a look at you. Give me 1 second. Somehow I messed up my deployment somehow. Oh, here it is. Okay. So notice there's a whole volume section here inside of my configuration for the Jenkins CI/CD pod. Notice that there's a whole setup for plugins, right? There's a plugin directory, right? And so what ends up happening is that there's a bunch of volumes that are actually being mounted. Some of these, by the way, are secrets. Some of these are config maps. So secrets are ways of mounting information inside of a container / pod that only the application can see unless you decide to exec in there and go look at it, even if you have permissions, right? But what's happening is a lot of this is being called off of the secrets definition, which is further down. But notice that here's the volume mounts, right? Name plugins, here's the mount path, right? Here's another mount path. And as we scroll down, more volume mounts. Where is the actual definition? Volume mounts here. Should be towards the bottom, actually. No, this is all state. It's got pretty messed up, actually. There's a sidecar in here as well. Sorry, I must have messed this up. This was not the best example. But basically what happens is that you are defining your storage class, you're defining your persistent volume, and then you make a claim against the volume in question, and it's based on the storage class. And that's really, the three of those work together to make sure that you can actually claim storage inside of Kubernetes. So tomorrow, I'll actually show you the production cluster that I usually run like a lot of my demos on, and we'll peel back actually how that's actually structured so you can see it in depth and in detail. So I'm not sure how that got mangled. I'm not sure what I was doing, probably troubleshooting something, mangled the wrong thing. Anyway, so that's how storage works, is that basically use a combination of storage class. You can do, by the way, dynamic or predefined persistent volumes, and then you make a claim against the volume, which then gets fed out. If the volume doesn't exist, but it's a dynamic volume, you can make a claim against it, and it will actually provision it on the fly for you, which is really nice in most environments where you actually don't know what your storage requirements are, but you're like in a cloud provider who can, in a sense, provide infinite storage, or you've got a large amount of storage to provide. You can just use dynamically provisioned storage in order to claim what you need at the time that you need it. Okay. Secrets, which we kind of touched on a little bit before, are just another form of storage. So whereas this is block storage, for the most part, right? There are exceptions to that. This is block storage that you write file systems on that you mount inside your containers, which are inside of your pods. This is a secret. And secrets are basically just small mountable objects that can be also mounted inside your pods / containers. And that basically contain sensitive information. They usually come directly from the etcd data store, right? And they're mounted as files so that you can actually like retrieve them and use them inside your container programmatically. In some cases, without having to expose anything to a repo or to be statically defined in a configuration file. The same secret, such as like a database password, for example, can be mounted in multiple pods in a system. And they don't even have to necessarily be in the same namespace or the same type. They just need to have the right permissions and the right setup to access the secrets. So Kubernetes itself uses secrets to manage itself, like it manage like everything it's got going on. And you obviously you can create your own secrets, which we just saw Jenkins doing that, right? There's an interesting statement here, which I don't know if it's true, and I actually have a little note to find out if that's still true even today, that secrets are stored as plain text in an etcd distributed data store. I don't believe that's actually true anymore, but I need to go confirm it because I remember seeing that on the release notes roadmap, and I don't think that's true as of 1.19. Because if they are stored in plain text, we still have the potential for abuse, right? Yeah. Okay. Let's see, where are config maps? Config maps aren't here. Weird. So config maps, as we saw from our dashboard setup earlier, config maps are basically similar to secrets, allow you to mount config files, for example, directly into your container, but it's pulling that information directly from maps that from key value maps that exist inside etcd, like inside the Kubernetes setup. Like for example, where another service is, or where local DNS is, or what your host name should be, right? So for example, here is an interesting set of data inside of a config map. This is basically generating a list of installed plugins. Yeah. Interesting. Right? So this is like metadata that you can mount inside of your container that can either run a shell script, it can be a flat file, it can be all kinds of stuff. Most people don't use this for executable data unless you need to dynamically generate a particular config file. Most of the time it's used to have like a static definition of information that the system's going to use when it boots up in particular. So interesting kind of setup there. But config map is missing here, but that's the other thing. You can mount like secrets inside of a container. Contains configuration information, which is why they're called config maps. Okay, last few pieces. And then we might not be at a space actually where we can do a lab, but I can at least share some things with you. Remember I said security was hard inside Kubernetes. It's a harder topic than the other topics. This kind of just barely scratches the surface around security in Kubernetes, right? But basically, you can pretty much control and parameterize any object inside of Kubernetes to be scoped the access-wise the way you want to. The only challenge is, excuse me, if you're in certain namespaces, or if you've got access to certain things like etcd, for example, if you're in kube-system, you may remember that was one of the namespaces that we had earlier, right? Kube-system. If you're able to like, if you have permissions to kube-system, that's also like is a problem. Like you have permissions to do pretty much anything, right? If you have control of the etcd database, you have pretty much control. Like if you have the ability to write and modify it, you pretty much have control over anything. That all being said, it's not like Kubernetes is a security problem. By default, it's not. Everything can be remarkably segmented. But like I said, it's a complicated topic, right? Because it does have attribute-based and role-based and federated-based systems that you can use, like RBAC and ABAC and all that stuff. It does have like webhooks you can put in. You can actually put in, all kinds of security policies. But it's not just like check and go, right? I wouldn't consider Kubernetes to be hardened by default. I certainly wouldn't consider it to be multi-tenant by default. I think there's a lot of error. And with like CVEs, like you may remember, oh gosh, what was it? CVE 2020-8854, 2020-8854, which came out in December, which basically allowed someone to just escape out and do all kinds of stuff inside Kubernetes. If my memory is correct, I know 8854 is the right number. I can't remember the exact details. So authentication authorization is just the beginning of a big conversation about how to manage role bindings, right? Roles inside Kubernetes, how to run cluster roles and cluster role bindings. There's actually a whole security class that we teach that is much like more robust around the topic. But just know that you do have role-based access control based on whatever roles you have set up, and in having certain like API calls and definitions attached to them that are bound to that particular object in question. You can also do it based, attributes, like in a file as an example. And you can actually integrate with third parties, but that does still actually use RBAC and ABAC in various combinations. Today, most people are focused on role-based authentication as the main method, using some kind of open policy agent with an admission controller to kind of control permissions. And if you didn't understand like half of what I just said, don't worry, we're gonna peel some of that back as we go on the next 2 days. But just know that, like I said, security is one of the hardest topics. It's one that I'm still continuing to evolve with. Like people are now moving away from PSPs, which I think someone mentioned earlier, and they're moving more towards like OPA gatekeepers, right? So like this is a rabbit hole of a topic. But just remember this: you can do access control based on roles. You can do access based on attributes, and you can kind of push that out to a third party via like SAML assertions, via webhooks and other components if you want someone else to do the authentication and authorization for you. Most of that's really easy to do. Hooking in it is easy. Getting the right security is not easy. So the other complicated topic inside, inside Kubernetes is, of course, routing. Because you may remember when we talked earlier, right, we talked about how the pod has a networking space, the cluster has a networking space, and then when it routes out, it has another networking path that it follows. So again, considering that this is supposed to be an introductory chapter about these different concepts as we dive in other portions, let me just emphasize this just briefly. I didn't want you to go over there. Bear with me. There we go. All right, so here we are in a pod. You got basically a loop back and a virtual interface. And inside this, by the way, is some containers, and they can all talk to each other. Right? They can talk to each other. Remember, they're sharing the same networking space, same internal space with each other, memory and networking. So they can talk to each other. Now, when this pod wants to go out, right, across this like overlay network for the most part, it's gonna have to pop out here. It's gonna have to talk to another virtual interface in that side of the system, which is basically representative to a certain degree of the cluster. Most of the time, this is using Open vSwitch, right? And then it basically nats out and then comes out here to hit the internet. But how does this natting routing occur, right? Somewhat of a mystery a little bit, right? Because this is probably a 172 address. There's a 10 address somewhere involved in here, right? Where is that happening? And then what's the IP address of this system? Well, this IP address may also actually be another 10 address, another 172 address, or some other address, but it's usually not the same IP range. You don't usually have to worry about conflicts there, right? So there's all this translation happening. Let me clear all this out. Just to get from here to here, through here, out to here, and the same path might be followed to go backwards this way, right? So we have a little bit of a section later on to kind of peel this out a little bit, but note that inside this particular space, there's networking happening. That's usually a private RFC address. Honestly, usually a 10. And then there's networking happening here between the pods themselves and the overlay with the cluster, which is usually a 172 address. And then there's other networking happening here on the other side of the interface in the switch that isn't necessarily always a 172 address. Sometimes this is a 10. And then of course it gets netted out to the primary interface for the box, which then is going to roll out to the internet. So there's about anywhere from 3 to 4, depending on what CNI you're using, which basically which provider you're using, whether it's Flannel or Cilium, Calico. What the Cilium, Calico probably good examples, but like the Cisco driver, the AWS driver, the Azure driver, there's at least 3 networks worth of networking happening inside your stack. So we're gonna dive into that at some point in time here over the next 2 days. I just want you to be aware. Like I said, this is one of the more complicated topics. You throw service mesh on here, by the way, and then you've got yet another overlay network that is connecting all of your namespaces together. Okay. So just remember that it was complicated. I'm sure you won't forget. All right, last but not least, I think we said this earlier. You need a registry for your cluster to work. So they list this as an option because it is actually required and important, right? Is that you have a registry of some type for it to function. Whether you want to repurpose Artifactory or JFrog or some other open source tool for that, that's totally fine. But just remember that you do need a registry. It should be private, honestly, and it should be scanned and repoed and versioned and all that stuff, right? Harbor, by the way, is a great product for that. It's part of the CNCF project. So just know that there's tons of options for you to run your private registry in your system. There are a couple of objects that weren't covered in our last few minutes. Just want to make sure that we talk about this. Is that while pod is the basic unit of deployment, there are other actual deployment types that are actually important for you to know. They're not necessarily included in the list there. For example, daemon sets. Anyone use daemon sets before? Has a deployment type? So if you're running a container and you stick it into a pod, which is scoped by a deployment, by the way, which deployment actually is usually the way that we deploy these things. The deployment has all the declarative statements that says, hey, I want this many, this copy, this is where it comes from, these are the volumes attached to it, these are all the configurations, right? Well, what happens is that if you say I want 4 pods and there's 50 boxes, it's going to try and run those pods on boxes separate from each other, right? And so it's going to run on 4 different boxes. But if resource constraints are what they are, you could end up with a pod on the same box, but it tries not to do that. It definitely, for the most part, it tries to distribute them across all the boxes. Make it sound like a living entity. It tries not to do that. Daemon sets, by the way, are pods that are going to run on every single node in the cluster. So when you run a daemon set, for example, let's say you have a monitoring agent that you want to run on every single node in the cluster. Every time a node is started, it's going to run that particular daemon set on that particular node. So let's say you're using, for example, CloudWatch, which is AWS's monitoring tool, and you're running the agent. You want every single node to have it. You run a daemon set and it will run on every single node. And so if Kubernetes adds nodes, it's going to put it on there. If it deletes the nodes, it's going to delete it, right? And by the way, it will not evacuate a daemon set off of a system in the event that that system becomes unreachable from either networking or some other problem. Like there's one other condition, networking, unreachable. Oh, not ready. That's the other option. So it's going to keep the daemon sets on there, right? And so daemon sets are used when you want to run deployments where you want every single virtual or physical node to have an instance of the thing in question. The other deployment type, other than jobs and cron jobs, that's probably pretty important is stateful sets. Stateful sets allow you to define persistent data attachments, right? Like to Jenkins as an example, where you basically attach persistent and permanent storage to a system. You can also put pods in relationship to each other. It says, look, I need to run these guys in a certain context with each other because I've got a web server and a database server, and these are 2 different pods, but I need to orchestrate these things together, right? So stateful sets are necessary when you want to create a relationship between pods, but also if you want to run attached storage to a pods and retain some level of state. That's what stateful sets are for. The rest of this we touched on in some form or fashion. We mentioned persistent volumes already. We didn't really talk about roles, role binding, cluster roles, binding, but we'll run into that. And service accounts, by the way, is not a new concept. Service accounts are when you need to run a service as an identity. This exists in cloud providers and in other concepts. Service accounts are when you just need to run an application as another identity. That's what they basically service accounts are for running services, right? So those are the like last objects I wanted to make sure that I mentioned. All right. That's our skim of all the objects in Kubernetes. Any questions about any of that? Does it feel like we're done? Feels like the end of the day, doesn't it? Feel like we've been in class all day long. Brains are a little burned. It's like post lunch. You're like, I don't even know what that guy said for the last hour. Thank God he's recording it. Right?
Actually,
So,
where's that GUI from? Is that a standard GUI that's provided by the Kubernetes project that most end users are using?
yes, it is standard for the Kubernetes project. You can actually find it in their repo. It's just called the Kubernetes dashboard, right? Minikube, like most things, just makes it really easy to run it by just typing in Minikube dashboard. But that's an official Kubernetes project. It's actually inside the Kubernetes repo. So you just install it, right? It just runs as a container, oddly enough, inside one of the namespaces, Kubernetes dashboard namespace. So I don't typically end up being able to use the GUI in production, but it's great for teaching. Like it's great for being able to show like these concepts visualized, right? I certainly don't use it for management typically. I felt even weird just kind of like hitting the replica button because I don't usually do it that way. So, all right. So what are we gonna do tomorrow? Just to give you a summary. So first, we're gonna review everything that we did today. It's gonna take about 30 minutes, but we're gonna go back through everything we talked about today. Just not like in detail. You're like, Michael, no, not again, right? We're just gonna go back through the highlights. I'm gonna ask you questions. Do you remember this? What's the flag for this? All this, just to reinforce the learning. So don't worry, I'm not gonna go back through every slide, right? Then we're gonna talk about application administration, the cluster administration overview itself, and then planning and designing a Kubernetes cluster. I wanna leave you with this. So maybe this is the last thing, which you do not even need to even remotely look at until the morning, because I hope you just give your brains a rest. But I'm a big fan of actually curated lists, especially if the lists are actually maintained. Anyone know what I'm talking about? That makes me mad to see lists that are like 3 years old. Just delete your stuff, right? Because 3 years is a lifetime, right? But there's a gentleman whose name I can't pronounce, who has a great list that I actually refer to myself pretty regularly. It's got some great stuff on it. So I'm just going to share that list with you. If you're looking for security information on Kate's, I actually go to his list and try to catch up with him on a pretty regular basis, and I'll repost this in the morning. But he's got everything from talks to like community links. He's even got jobs on there, which just cracks me up somewhere. References for like different CVE, CKED. He is missing, by the way, like some of the latest CVEs, but quite frankly, I wouldn't expect him to kind of keep up on that, frankly. 8854 was just like 4 months ago. But that's it. That's all I got for you today. That's what we're doing tomorrow. Does anyone have anything they need to share with me? Questions, concerns? Okay. Well, if we're all good, then let's be done. So
Thanks,
I'll catch you tomorrow at 8:30. All right, everyone. Have a great night. Good evening. Rest, relax. See you tomorrow.
Thanks. Good night.
Good night. Secrets, that's right.